It's happening right now. 3 Atlas has passed behind the Sun. For the first time since its discovery, no telescope on Earth has a direct line of sight to the object. The perihelion phase predicted for 1142 UTC has begun, and the data feed from several monitoring observatories has gone quiet almost simultaneously. Early this morning, infrared arrays in Hawaii detected a final surge in luminosity, an abrupt brightening of nearly 22% before contact was lost. The signal pattern wasn't consistent with a flare or normal outgassing. It carried a sharp spectral edge, the kind seen in engineered light sources rather than thermal emissions. Within minutes, solar interference drowned the reading entirely. Since then, every major telescope network, from the Very Large Telescope in Chile to the James Webb Observatory at L2, has reported temporary blind zones or corrupted data frames near the object's coordinates. Agencies are calling this expected solar interference, but the timing down to the minute align with what independent analysts warned might be a maneuver, the moment when 3 Atlas and the 9 reported companions disappear behind the Sun together. As of 14 UTC, no reflected signal, no dust plume, and no debris trail have been confirmed. It is as if the entire formation simply stepped out of view. Governments remain silent. The European Space Agency issued a 2-sentence statement describing nominal perihelion parameters. NASA Jet Propulsion Laboratory deferred comment until post-conjunction data recovery. Meanwhile, private radar arrays continue to sweep the region, searching for any outbound vector once the object emerges on the far side in early December. For months, we've followed this object. Its trajectory, its impossible stability, the unexplained energy signatures. Now, it's entered the only place where no one can watch. What happens in the next 48 hours will determine whether the story of 3I Atlas ends as a natural enigma or begins as something engineered. This is October 29th, 2025, the day the Sun hides the most mysterious visitor our system has ever received. Let's go through what we know, what we lost, and what might be waiting when it comes back into view. For the first time since its discovery, 3 Atlas cannot be seen. Every telescope capable of tracking it has entered what astronomers call solar conjunction blackout, a period when the Sun's glare overwhelms sensors and communications. Normally, this phase is routine. Spacecraft enter it, comets pass through it, and data resumes days later. But this time, the blackout arrived under a cloud of unresolved anomalies. The final preconjunction readings came in at 1142 UTC. Both NASA Infrared Telescope Facility in Hawaii and the European Southern Observatory in Chile recorded a brief coordinated surge in brightness, a pulse lasting only seconds before total signal loss. Instruments confirmed that the spike wasn't consistent with normal outgassing. There was no corresponding dust plume, no increase in the coma. It looked more like a controlled flash than a natural flare. Then everything went dark. In previous weeks, 3I Atlas was already an outlier. Its trajectory was hyperbolic but unnaturally stable. Its rotation steady even as solar heating increased. 9 smaller objects first reported in mid-September appeared to match its speed and orientation perfectly, an impossible configuration for random fragments. Together they moved as if bound by invisible tethers, maintaining precise spacing while approaching the Sun at nearly 68 km/s. That formation now lies directly behind the solar disk. The silence has left researchers divided. At Caltech's Minor Planets Center, analysts argue that the blackout is entirely expected. Data transmission near perihelion is notoriously unreliable. But within independent observatory circles, the tone is different. Private spectrographs in South America, still scanning the solar limb, report narrow-band interference signals not attributable to the sun. Nothing conclusive, just static bursts in a pattern that repeats every 47 seconds. Coincidence perhaps, or something operating beyond line of sight. Space agencies have gone quiet. The European Space Agency released only a single sentence. Observations of 3I Atlas are temporarily suspended during conjunction. NASA Jet Propulsion Laboratory postponed its briefing, citing the need to analyze anomalous radiometric returns. Even the Galileo project team, usually vocal online, has refrained from comment. Across scientific channels, the flow of updates has stopped. For now, all that remains is the data gathered in the final 24 hours before the blackout, hours in which something appeared to change. The 9 companions' infrared signatures grew stronger relative to the main body, suggesting internal heat generation rather than reflected sunlight. At the same time, radar backscatter from the main object weakened, as if its surface composition shifted or its cross-section reduced. None of these changes fit known models of cometry behavior. Astronomers call this period the blind arc. It lasts roughly 2 days for an object this close to the Sun. After that, 3 Atlas should re-emerge on the opposite side, moving away from perihelion. If it appears precisely where orbital mechanics predict, the anomalies might be explained as observational noise. But if the trajectory deviates even slightly, if the object emerges early, late, or at an unexpected angle, it will mean that some form of non-gravitational force acted on it during conjunction. And that is the crux of the tension tonight. No one can observe, no one can measure. For 48 hours, the object exists in silence, unreachable, unconfirmed, unseen. Yet the last data points before disappearance suggest activity rather than decay. Energy increasing, not fading. Alignment holding, not drifting. As one astrophysicist wrote anonymously this morning, the problem isn't what we can't see. It's what we saw right before it vanished. The world waits for the sun to turn and reveal what's left or what's changed. Until then, the silence itself becomes the message, and that silence is louder than anything else in the sky. At 11:4156 UTC, a final pulse appeared in the data stream from the Gemini South Observatory. It lasted only 4 seconds, sharp, coherent, narrow band. The signal wasn't random noise or a standard thermal flare. Its frequency peak stood out precisely at 1420 MHz, the hydrogen line used for deep space communications and radio astronomy calibration. Then it vanished. A heartbeat later, the main telemetry feed collapsed under solar interference, and the object was gone. That final moment, recorded simultaneously by 3 facilities, became the anchor point for every analysis now unfolding. What happened in those 4 seconds has divided the global science community. To some, it was an artifact of solar plasma scattering. To others, it was an intentional broadcast time to perihelion. The coincidence is impossible to ignore. The signal appeared exactly when 3 Atlas and its 9 companions crossed the solar limb from Earth's perspective, entering the Sun's blinding corona. For a natural object, the odds of such perfect synchronization are vanishingly small. In the hours that followed, scattered monitoring stations across the southern hemisphere reported flickers of secondary noise. Amateur radio arrays in Argentina, South Africa, and Western Australia detected faint harmonics drifting upward in frequency, almost like an echo. These weren't official detections. They lacked calibration, control, or peer verification. Yet, the timing lined up to the minute with the blackout phase. Nothing conclusive, but enough to keep professionals awake. Inside NASA Planetary Defense Coordination Office, emergency analysis protocols went active. A cross-disciplinary team began passing raw data from the Deep Space Network, searching for reflected radar signatures that might reveal where the object would re-emerge. So far, the models hold steady predicted exit coordinates just beyond the Sun's western limb around December 6th. But if the object altered velocity by even 0.5% during conjunction, that emergence point could shift millions of km for an interstellar body, moving at nearly 68 km/s. Even a min-up thrust could rewrite its orbit entirely. Meanwhile, in Boston, JAVL's Galileo project team uploaded a public notice acknowledging the perihelion blackout. The message was brief: all current data consistent with observational uncertainty, awaiting post-conjunction requisition. Behind the measured tone, internal correspondence leaked within hours. Researchers debated whether the 1,420 MHz pulse was a calibration artifact or a potential emission event. One line later verified reads simply, "If artificial, it chose the one frequency we'd all notice." Elsewhere, the tone was more restrained. At Caltech, orbital mechanics specialists argue that any apparent coordination among the 9 companions could still stem from a fragmentation event. The fragments sharing the parent's velocity vector would appear to move in formation until differing solar pressures gradually scattered them. The problem: those fragments never separated. Even in the final pre-blackout frames, their spacing remained precise. Kilom-scale alignment across tens of thousands of km of travel. Natural debris doesn't behave like that. The debate now centers on energy. Earlier infrared readings suggested each companion emitted power on the order of 20 GW, implausible for inert rock. Yet the math behind those estimates relies on uncertain albedo and temperature assumptions. If the object's surfaces were unusually reflective or composed of exotic ices, apparent power output could be overstated by orders of magnitude. Still, some physicists find the consistency across instruments hard to dismiss. As one analyst noted, different telescopes, same readings. That's either universal error or universal signal. Behind the public calm, quiet mobilization continues. Tracking stations normally devoted to asteroid defense drills have been reassigned. The U.S. Space Force confirmed additional radar windows dedicated to the object's projected exit point. China's CNSA extended operational hours at its Yuan Wang tracking ships. Officially, these are standard coordination measures. Unofficially, they reflect growing unease about what might appear once 3I Atlas clears the sun's glare. Historically, comets approaching perihelion brighten, fragment, or fade. They don't disappear cleanly. The absence of a dust trail behind 3I Atlas is striking. Even at extreme temperatures, no measurable outflow was observed. No vapor jets, no dispersing tail. If the object was shedding material, we would detect sodium or water lines in the spectrum. Instead, the spectrum flattened, its brightness steady until the final pulse. Whatever 3 Atlas is, it's either more stable than any comet on record or something else entirely. For now, scientists rely on models rather than images. Simulation clusters at JPL and the European Space Operations Center run constant permutations, varying mass, spin, and composition to predict post-P perihelion behavior. Every model still yields the same outcome. The object should survive the solar P intact. But no model explains the energy readings or the companion formation. That uncertainty is why this silence feels heavier than usual. Tonight, the world looks toward a sun that hides more than it reveals. Somewhere behind that incandescent wall, 10 unidentified bodies race through plasma dense enough to destroy metal. If they emerge unchanged, we'll call it endurance. If they emerge rearranged, we'll call it intent. Either way, when the first signal returns from the far side, astronomy will record not just data points, but a before and after in how we understand interstellar visitors. For now, the last thing Earth heard from 3I Atlas was a whisper at the hydrogen line. Then nothing. That silence is the story, and it's only just begun. In the absence of live visuals, the entire investigation has turned to archived data, the final 60 hours of observation before blackout. Frame by frame, pixel by pixel, analysts are reconstructing what the sky saw when 3 Atlas still reflected sunlight. The footage looks almost motionless at first, a dim green streak against deep space black. But when the contrast is pushed and the frames are overlaid, the formation becomes unmistakable. 9 compact points, each holding a fixed distance from the primary body. No drift, no dispersion, no rotation. The geometry of control. The first confirmation came from the Very Large Telescope in Chile. Using adaptive optics, researchers measured micro-variations in brightness that revealed a rhythmic pattern, each companion brightening and dimming in sequence every 7 minutes 49 seconds apart. That timing is far too regular for tumbling debris. When the same pulse sequence appeared in images from Gemini North in Hawaii and the KEK infrared array, cross-checking removed nearly all chance of coincidence. What looked like flicker was synchronization. Data engineers at the European Southern Observatory began plotting separation ratios. The results stunned even skeptics. Every companion's distance from the primary matched a Fibonacci progression within 0.5%. In natural systems, that sequence shows up in orbital resonances and spiral galaxies, but only as emergent, not perfect order. Here, it was exact as if designed. If that geometry holds true once the object re-emerges, it will be the first recorded instance of non-gravitational formation maintenance beyond the solar system. Skeptics argue that the symmetry could still be an artifact. When faint sources are deconvolved near bright ones, software can create phantom alignments. The counterpoint, 4 separate instruments operating in different wavelengths reported identical spacing. The likelihood of identical software artifacts across independent pipelines is practically nil. The pattern matters because of what it implies. A symmetrical formation around a central mass means interaction, magnetic, mechanical, or directed propulsion. There's no sign of dust bridges or tidal shearing. So, gravity alone can't bind the cluster. If each companion is truly maintaining its station at 68 km/s while accelerating around the Sun, it would require coordinated thrust corrections accurate to centimeters/s. For comets, that precision is impossible. For technology, it's routine. At Harvard, the Galileo Project's dynamic simulation team modeled what such control would require. Their estimate, continuous micro-impulses delivering only a few newtons each, perfectly phased across all bodies. The energy budget fits roughly with the reported 20 gigawatt thermal emissions, enough to power such adjustments without exhausting material reserves. But that model assumes systems designed for navigation, not evaporation. Still, the possibility of coordinated movement doesn't make 3 Atlas an alien craft. It makes it an anomaly. Nature has surprised us before. Mu's acceleration once seemed impossible, until subtle outgassing provided a partial answer. But the similarities stopped there. MUA tumbled chaotically. 3I Atlas rotates with clockwork precision. Umamura dimmed unpredictably. 3I Atlas brightens on a schedule. Each layer of comparison erases the comfort of precedent. In data centers around the world, scientists are now replaying the last clean minutes before the Sun claimed the view. They're not looking for spectacular images, just drift. Any sign that the companions wavered in formation. So far, none has been found. Every trajectory remains locked, every separation constant. The cluster moved as one right until the light disappeared. And that leads to a deeper question. If 3 Atlas truly maintains structural alignment through perihelion, what happens when it reemerges? Will the formation remain intact, or will it disperse as natural fragments should under solar stress? If the geometry returns unchanged, the conclusion will be unavoidable, that some active system preserved it through temperatures exceeding 500 degrees C and radiation flux thousands of times greater than Earth's. Governments and agencies are preparing for both outcomes. NASA has already scheduled the first post-conjunction tracking windows using the Solar Terrestrial Relations Observatory probes positioned off-axis from Earth. Those probes might regain partial contact weeks earlier than ground telescopes, giving the world its first hint of what survived. A single reflection, a single trajectory ping will tell the story. If the vectors match predictions, the event will fold back into known physics. If they don't, every model of interstellar behavior will need rewriting. For now, the formation data sits locked inside servers, frozen in the hours before silence. Analysts describe it as eerie to watch the object gliding toward the sun, while its companions trace perfect arcs beside it like an ancient pattern repeating through plasma. Then abruptly the frames end. The last image captures a faint glint on the leading hemisphere, a momentary flash and blackness. No one knows whether that flash was reflection or ignition. No one will know until December, but the geometry it left behind remains undeniable. 10 bodies, 1 path, 1 impossible order. In the language of observation, that's called correlation. In the language of curiosity, it's called a question we can't yet answer. And right now, that question is crossing behind the sun. In the hours following perihelion, as Earth's view remained cut off by the sun, deep space instruments operating far beyond our planet's orbit began picking up unusual noise. The Solar and Heliospheric Observatory, SHO, positioned at the L1 point, recorded a short burst of ultraviolet radiation just after the expected time of maximum solar proximity. It was subtle, barely above background solar activity, but its spectral profile did not match a solar flare. Instead, it had a narrower wavelength band and an oddly symmetrical pulse shape, as though it originated from a single directional source. Analysts at NASA Goddard Space Flight Center, CROSS, referenced the timestamp with the known trajectory of 3I Atlas. The overlap was near perfect. The emission occurred exactly when the object should have been closest to the sun's corona. Normally, a comet at that range would erupt into a chaotic plume of ions and debris, but the S imagery showed no outward burst, only a flash, then nothing. If 3I Atlas had fragmented, sensors would detect an expanding halo of dust. Yet all readings returned clean. No debris trail, no expansion, no residue. That clean absence is what troubles researchers most. Every natural model predicts chaos at perihelion, not precision. The object should have boiled, fractured, or vaporized. Instead, its radiometric signature suggested a sudden surge of controlled energy, like a system bracing against the solar flux rather than succumbing to it. For planetary scientists, that interpretation feels almost heretical. But for those following the data, it fits the pattern too neatly to dismiss. Hours later, the Parker Solar Probe, already within 0.3 astronomical units of the Sun, detected electromagnetic interference near its telemetry band. The disturbance repeated at regular intervals of exactly 1,420 MHz, the same hydrogen line frequency that had surfaced in the pre-blackout signal. Engineers initially flagged it as cross-talk from terrestrial sources, but the probe was far beyond Earth's radio reach at that point. The pattern was faint, almost lost within the roar of solar plasma, yet unmistakably structured. Each pulse carried the same separation gap, 47 seconds. The coincidence was enough to reopen quiet conversations within the Galileo Project ETI circles. If the 1420 MHz tone appeared both before and after perihelion, it suggested deliberate continuity, a transmission bracketed around the period when the object was invisible. That possibility sits halfway between physics and speculation. For some, it hints at signaling. For others, it represents an artifact of instrumental resonance. But no one can yet explain how a consistent signal could persist through the sun's ionized barrier, unless generated enormous power, or from beyond the solar limit itself. Meanwhile, energy budgets are being recalculated based on the last verified infrared data. Each of the 9 companion objects appear to maintain constant internal temperature, even as solar intensity quadrupled. No known volatile compound can sustain that stability. Cometry cause heat unevenly, develop jets, and lose mass rapidly. These did not. The models that fit this behavior require continuous internal power regulation, something akin to thermal control. And that raises the question scientists prefer not to voice aloud. Are we observing material physics or mechanism? Official statements continue to tread carefully. NASA Planetary Science Division described the event as anomalous but likely natural, promising a formal report once post-conjunction tracking resumes. The European Space Agency released raw SO frames with no interpretation, leaving independent researchers to extract their own readings. But leaked communications from within JPL suggest mounting tension. One memo notes, if the trajectory deviates by more than 0.0202 astronomical units on reappearance, artificial acceleration cannot be ruled out. In parallel, private observatories are watching the solar perimeter for reemergence indicators. Tiny changes in brightness that might signal motion behind the corona. Thus far, nothing, but data from the Indian Space Research Organization's Adisha L1 satellite, which monitors solar radiation from a slightly different angle, shows a faint dip in the extreme UV range, recurring every 8 minutes. It's not enough to draw conclusions. Yet, the timing curiously matches the rotation period inferred from earlier observations of 3I Atlas. If these modulations hold, they could represent the object's thermal signature bleeding through the sun's edge. The amplitude remains constant, suggesting resilience under heat that should destroy any volatile-rich nucleus. The energy required to maintain such stability would exceed that of a small asteroid's total mass converted into outgassing. That leaves 2 explanations: unknown material properties or an internal energy source. The implications ripple beyond astrophysics. If the perihelion event confirms controlled energy release, 3I Atlas becomes the first recorded example of a non-natural energy system operating in interstellar space. Even a faint hint of that possibility has triggered quiet contingency planning. Defense coordination networks are running spectral comparison drills, ensuring that no terrestrial or near-Earth systems are mistaken for returning signals. Within SETI encrypted working groups, researchers have been instructed to isolate the 1420 MHz data and avoid public release until corroborated. No one uses the word contact, not yet, but the vocabulary has shifted. Where early reports spoke of activity, internal memos now refer to output. The language of geology gives way to the language of engineering. Scientists are cautious. Rigor demands skepticism, but the private tone in their correspondence reveals unease. Too many patterns align, too many signals repeat. The silence since the 29th is not the empty kind that follows an observation gap. It's the strategic quiet of institutions processing information they cannot yet explain. The next opportunity to detect 3I Atlas comes when it clears the solar limb in December. Until then, the The question stands like an equation waiting for balance. If energy cannot be created or destroyed, where did this energy come from? And why was it released only when the world couldn't see? As of tonight, all we have is the residue of a pulse, the trace of structured frequency, and a line of numbers that shouldn't exist. The event may prove natural, or it may redefine what we consider possible. But either way, the hidden energy recorded on October 29th has transformed 3I Atlas from a curiosity into a variable that physics itself now has to chase. The world has entered the waiting phase. The object is gone from view, submerged in solar glare and data silence. And yet, the tension feels louder than any signal. The blackout has become global. Every deep space network, every infrared array, every radio telescope is focused on the patch of sky where 3 Atlas should be. But all that returns is static. The sun has swallowed the signal completely. Inside control rooms from Pasadena to Darmstadt, monitors glow with empty graphs. Data technicians watch scrolling zeros, waiting for the slightest rise in the baseline noise that might mark requisition. Engineers describe it as staring into the quiet side of physics. The Deep Space Network's Canberra node continues transmitting diagnostic pings at 1-minute intervals. Nothing comes back. The silence is deceptive. For space agencies, perihelion blackout is predictable. But the lead-up to this one wasn't. It carried too many coincidences. Brightness pulses, synchronized formations, repeating signals. To the people who have followed 3I Atlas since July, the current quiet feels deliberate, like a curtain drawn before something rehearsed. It's the sense that this pause is not an accident of geometry, but part of the sequence. In Boston, the Galileo project's secure server logs show round-clock computation runs. Analysts are testing every natural variable that might mimic intelligent patterning, rotational harmonics, magnetic flux coupling, electrostatic tethering, even synchronized sublimation waves across multiple fragments. None of them fit. The only models that reproduce the formation's motion require coordination, the precise kind used in swarm drone formations on Earth, scaled up by millions of kilom. Still, correlation isn't confirmation. The cautious voices remain the loudest. Miyakaku's laboratory team released a short statement through Caltech's outreach network, arguing that observers are romanticizing data noise. They point to historical analogues, comets that split in equal parts, fragments that maintained near-identical velocity for weeks before separating. But even they concede that the current readings don't behave like outgassing fragments. The emission curves are too steady, the spacing too clean. If it's coincidence, one physicist admitted off record, then it's the neatest coincidence in cosmic history. Meanwhile, the outer probes are listening. Parker, Solar Orbiter, and the Helios 2 successor all continue scanning for residual radiation near the Sun's western limb. Nothing definitive yet, but small phase anomalies keep appearing. Brief distortions in the solar wind, as if something is shaping the plasma flow from within. They last seconds, then fade. Each time, the time stamps a line roughly with the projected path of 3I Atlas as it moves behind the Sun. If these distortions continue at the same periodicity, analysts could triangulate an approximate vector, a crude way of tracking the invisible. Beyond science, the story has crossed into policy. On October 30th, less than 24 hours after the last confirmed signal, the UN quietly convened an emergency subcommittee on non-terrestrial observation contingencies. It wasn't broadcast, no press releases, but diplomatic calendars confirmed the meeting. The agenda listed only one line: potential coordination following anomalous perihelion event. The phrase says nothing yet implies everything. Behind closed doors, governments are preparing for the possibility that what emerges in December may not be inert. The public, though, knows none of this. Official channels keep the message simple. Temporary data gap, object stable, no cause for concern. Even so, forums and message boards teem with speculation. Amateur radio operators continue scanning the hydrogen band, convinced that if 3 Atlas emitted once, it might emit again. Some claim to have heard faint rhythmic tones. Others post static bursts they interpret as encoded patterns. In reality, solar noise at that frequency can produce almost anything. But the global fascination shows how deeply this mystery has entered the cultural bloodstream. Scientists, by contrast, have become strangely quiet. For months they debated openly, posting updates, sharing spectra. Now their silence mirrors the sun's. They are waiting, cautious not to overstate what might prove a mirage. Yet, internally, the phrasing in reports has shifted. The latest draft from the International Astrophysical Data Consortium includes a new term, controlled thermal response. It replaces active outgassing semantics, perhaps, or the slow migration of thought from geology to engineering. Somewhere beyond that blinding horizon, 3I Atlas is experiencing forces we can't model. Its forward face is exposed to temperatures exceeding 600 degrees and radiation flux strong enough to ionize any known ice. If it survives intact, it will confirm that its composition is not cometry at all. If it reemerges altered, brighter, larger, or trailed by debris, we'll know that Perihelion stripped it bare. But there's a third outcome that few mention aloud: reemergence elsewhere. A shift in exit vector, even by a fraction of a degree, would place it far from its predicted path. An intentional change rather than a natural one. Every scenario is running through simulation cores tonight. The models project that if 3II Atlas executed a controlled turn, using photon pressure or directed mass ejection, it could adjust its trajectory enough to rendezvous with outer solar system bodies by late 2026. Sounds far-fetched. Yet so did everything else about this visitor. Until confirmation arrives, Earth remains on the blind side of knowledge. For the next 36 hours, the object's fate exists only in equations. And equations, unlike human witnesses, do not speculate. They wait. So does the world. The sun rotates, the sensors hum. And somewhere in that glare, the story of 3 Atlas continues unseen. A silent paragraph in the universe's longest manuscript, waiting for the next page to turn. The first sign of movement didn't come from NASA or the European Space Agency. It came from the ground, from an observatory outside San Pedro de Atacama, Chile, where amateur astronomers had been recording every night since the blackout began. On November 1st, just 48 hours after the last confirmed signal, their data logs captured something faint but consistent. A cluster of 10 thermal signatures reappearing at the edge of the solar exclusion zone, several hours earlier than orbital predictions allowed. At first, the readings were dismissed as ghosting digital after images caused by sensor heat. But when the same pattern appeared in 3 independent data sets, the coincidence became impossible to ignore. The alignment, spacing, and intensity matched the last known configuration of 3I Atlas and its 9 companions. Each point maintained identical distance ratios, each following the same angular velocity. The entire formation had re-emerged precisely where the object was not expected to be. The implications are staggering. According to every trajectory model, 3I Atlas should not have cleared solar interference until early December. Yet, here it was, detected by mid-infrared imaging barely 72 hours after vanishing. That means one of two things. Either the object decelerated dramatically as it approached the sun, or it changed course altogether. Both scenarios defy celestial mechanics. Astronomers in Chile spent the next 2 nights trying to replicate the result. They adjusted filters, recalibrated mounts, checked timestamps against NASA Deep Space Network. The pattern persisted. Each frame showed the same formation, moving eastward across the sky at a slower velocity than before, roughly 54 km/s instead of 68. The change was subtle but statistically solid. Somehow between entering and exiting solar conjunction, the entire system had lost nearly a quarter of its speed. Natural forces can't explain that. Gravitational drag from the sun is negligible at that distance. Solar radiation pressure exerts acceleration, not deceleration. Outgassing would produce chaotic thrust, not coordinated slowdown. Something else acted on the object, something with precision. When word of the chilly frames reached the European Southern Observatory, their internal communication shifted tone. The official public statement still described the data as inconclusive, but private memos leaked through internal channels revealed growing concern. One senior astrophysicist wrote, "If verified, this isn't a comet. It's under control." Another simply replied, "We've crossed into engineering space." Over the next 24 hours, telescopes in Argentina, Australia, and South Africa confirmed the same coordinates. Infrared measurements aligned within 0.1 arcseconds. Every observation supported the same improbable conclusion. 3I Atlas had performed a controlled deceleration near Perihelion and resumed motion on a slightly altered trajectory, angled 3 degrees north of the original path. Small, but enough to shift its projected exit point millions of km off course. NASA responded quietly. The agency requested all raw telemetry from the Chile observatories and imposed an embargo on further data release pending verification. No reason given. At the same time, the Deep Space Network began transmitting at 1,420 MHz, officially for signal calibration, though the timing raised eyebrows. The same frequency had been recorded in the final pre-blackout pulse. Some suspect the transmissions were an attempt to provoke a response. None came, yet radio engineers in Hawaii and Japan detected faint broadband echoes returning hours later. Not direct reflections, but low-energy distortion scattered through the ionosphere. The pattern wasn't random. It carried a slow oscillation repeating every 47 seconds, the same rhythm noted before perihelion. It could be coincidence, or it could mean that 3I Atlas was still active, still emitting, still listening. Meanwhile, the visual data told another story. The object's brightness had stabilized at levels too high for a mere fragment. Its spectrum showed an unusual dominance of metallic reflection. Nickel, magnesium, traces of cobalt, all highly reflective alloys that don't appear in bulk on comets. The green hue remained, but its source seemed to have shifted from gaseous emission to structural reflection. The tail had vanished entirely. What lingered was a solid body surrounded by 9 smaller nodes glowing faintly in infrared, each emitting heat without visible light. By November 3rd, astronomers had calculated a new trajectory. Instead of continuing outward along a hyperbolic escape, 3E Atlas appeared to be curving slightly, an arc that would take it toward the outer solar system. Yes, but on a path intersecting the orbital plane of Jupiter by mid-2026. That wasn't supposed to happen. The odds of a natural interstellar object adjusting trajectory to align with a planetary orbit are nearly zero, unless of course it was meant to. The reemergence data triggered immediate political reaction. Within hours of the Chile reports, the International Astronomical Union received joint requests from the US, China, and the European Union to classify all 3 Atlas observations under restricted access status. For the first time in modern history, data about a celestial object became classified material. No one explained why. Privately, several scientists resigned from observatory projects in protest. One leaked note reads, "We're no longer studying astronomy. We're managing disclosure." In Boston, Avi's team released a cautiously worded update. Infrared requisition from Southern Hemisphere facilities suggests non-gravitational acceleration consistent with previous hypotheses. Further observation pending verification. In private discussions, however, Lowe reportedly used stronger language, calling it the first empirical indication of engineered motion. Still, not everyone agrees. At Caltech, Miyakaku's group insists that a solar magnetic coupling event could have temporarily trapped the object in a flux rope, causing apparent deceleration. They argue that the energy readings reflect induced current within metallic-rich material, rather than artificial thrust. It's an elegant theory, except that the flux rope would have to be perfectly aligned to decelerate rather than accelerate, and even then, it wouldn't explain the sustained formation geometry. The data from Chile remains the focal point. Every pixel, every time stamp, every calibration note is being examined by teams around the world. No one disputes that the signatures are real. What divides them is interpretation. To some, it's the universe revealing a new class of interstellar body, metallic, reactive, and self-stabilizing. To others, it's confirmation that we're no longer observing nature alone. As of tonight, the coordinates have been locked into the tracking schedules of every major telescope in the Southern Hemisphere. When darkness returns to Chile, the lenses will point again at that faint, silent cluster drifting away from the sun. No one knows what they'll see next, but one thing is certain. 3II Atlas survived its solar passage, and it didn't emerge the same way it went in. By the evening of November 5th, confirmation was no longer in doubt. The global data pool from Chile, Argentina, and Australia aligned perfectly. 3 Atlas had altered its trajectory. Its new path diverged by 2.7 degrees from the one calculated before Perihelion, a subtle deflection that translated into a shift of nearly 30 million km at its next projected orbital intersection. What startled scientists wasn't just the scale of that deviation. It was the manner of it. The curve was smooth, gradual, and uniform, showing none of the turbulence typical of a comet reacting to solar pressure. Natural deceleration leaves fingerprints. Random gas ejections cause measurable spin shifts, brightness flickers, and wobbling motion. None of those appeared. Instead, every light curve record from October 28th onward displayed clockwork stability. No sudden jets, no torque variations, no debris release. The object changed course the way a spacecraft would progressively deliberately, as if following an algorithm. When NASA Jet Propulsion Laboratory released a partial bulletin acknowledging slight deviation in post-Perihelion trajectory, the wording was understated to the point of absurdity. Inside, analysts were in open disagreement. One internal note later leaked to a journalist at Scientific Frontier read simply "trajectory deflection detected, energy source undetermined." The data itself was plain. The Chiller team's new positional plots placed 3 Atlas on a shallow arc leading toward the ecliptic plane, a maneuver that would bring it into near-resonant orbit with Jupiter's path by March of 2026. That movement cannot occur through passive physics alone. To lose 20% of its velocity without disintegrating, the object would have had to convert kinetic energy into heat or thrust, neither of which fits any natural model. The numbers drew comparisons to one other event, the 1977 WOW signal. Its frequency was identical, 1,420 MHz, and it appeared without follow-up, as if something transmitted once and fell silent. Now, nearly half a century later, the same frequency kept surfacing in connection with 3 Atlas. On October 29th, it was a narrow-band pulse. On November 1st, Faint modulation recorded by Parker and again on November 4th. A structured harmonic detected by the Atacama Array. The persistence across instruments had statisticians recalculating probabilities. The chance of 3 independent systems detecting correlated signals at that exact frequency, or within the same solar window, is less than 1 in 10 million. Theoretical physicists began sketching out what a controlled deceleration might look like. The simplest explanation, if simple still applies, would be photon sail dynamics. By expanding reflective panels or energy fields at precise angles, an object could use solar radiation to brake against its own momentum. But that would require structural adaptation at perihelion exactly when the object vanished from view. It would also explain the surge in brightness noted by S and the sudden drop in velocity detected afterward. The pieces fit too neatly to ignore. Meanwhile, governments continued to tighten information channels. The International Astrophysical Data Consortium imposed an access freeze on all radar telemetry involving interstellar bodies, citing national security interests. For the first time, even civilian observatories found their data queues rerouted through centralized encryption servers. No explanations, no briefings, just silence. In private forums, astronomers grew restless. A thread on a secure academic network contained one line that captured the mood. If this were a rock, it would be a rock. It's not behaving like one. The deviation has forced scientists to re-examine another anomaly, the object's consistent temperature. If 3I Atlas absorbed full solar radiation during perihelion, its outer layers should have vaporized or at least released gases visible in ultraviolet spectra. Instead, its thermal output dropped slightly, implying that energy was either absorbed internally or redirected. Some compared it to a blade of shielding, others to conversion into non-thermal energy, propulsion. As models ran across supercomputers in Boston, Pasadena, and Tokyo, a pattern began emerging. The trajectory shift was not random. It was optimized. Calculations show that the new vector allows 3 Atlas to use Jupiter's gravitational field for a slingshot maneuver. Precisely the technique human spacecraft employment without fuel expenditure. No natural comet has ever executed such a trajectory, not one. The revelation spread quickly among Heil researchers. Leaked internal emails from ESA's Solar System Division included a short line from one director. If it planned this arc before perihelion, then it planned perihelion. Those words, though never intended for public eyes, captured the quiet disbelief of an entire field. Not everyone agreed. Miyakaku's camp continued to advocate for magnetic drag interactions between the sun's coronal mass ejections and a metallic-rich body creating temporary braking forces. But even Kaku's students admitted that such a mechanism couldn't produce uniform deceleration or perfect formation retention. You'd expect at least one fragment to drift, they wrote. None did. Every companion remains locked in place, spacing unchanged since September. In the public sphere, speculation now borders on hysteria. Social media fills with countdown clocks to December the 6th, the predicted date of full reemergence. Conspiracy theorists claim governments are concealing first contact. Skeptics counter with claims of mass misinterpretation. Between them, professional astronomers navigate the impossible, explaining unprecedented data without resorting to fantasy. For now, the safest language is neutrality. The official term used by the International Astronomical Union's emergency bulletin is self-consistent acceleration, anomaly. Technically correct, practically meaningless. Behind the scenes, however, the tone is shifting from disbelief to logistics. Several agencies have begun adjusting satellite observation schedules in anticipation of 3 Atlas's return to visibility. SpaceX and Blue Origin have been quietly asked to prepare their tracking platforms for possible infrared detection runs. None of that appears in public press releases, but launch manifests tell their own story. Every hour of silence after November 5th stretches like a tether between reason and speculation. The equations remain exact, the motion too deliberate, and the questions too vast. Something slowed down through the atlas. Something guided its path. And if its curve toward Jupiter holds, the next time it comes into full view, humanity will face not just a visitor from another star, but an object that chose where to go next. For now, Earth waits. The sun has turned. The shadows are lengthening. And somewhere beyond that glowing horizon, 10 silent travelers continue along a trajectory that no longer belongs to chance. November 8, 2025. The blackout had stretched for nearly 10 days, and tension inside observatories reached a breaking point. The world's telescopes remained trained toward the region of space where 3 Atlas should have emerged. Yet the silence persisted. No visible trace, no radio echo. Then, without warning, an anomaly appeared on the spectrum monitors of the Allen Telescope Array in California. A faint but sharply defined narrowband pulse at precisely 1,420.4405 MHz. It lasted 53 seconds. Just one pulse, fading smoothly into the background. No harmonic, no modulation, no repeat. At first, technicians assumed interference, a calibration error perhaps, but the automated filters had already stripped all terrestrial sources, and the signal originated from a sky coordinate matching the Chilean requisition path, only now shifted slightly west along 3 Atlas's new projected trajectory. When cross-G'd with data from a South African dish, the timing matched within half a second. It was real. What made the reading more unsettling wasn't its existence, it was its structure. The waveform displayed 3 distinct amplitude peaks spaced evenly apart, each separated by 47.2 seconds, the same interval observed before Perihelion, recorded again after the Chile re-emergence. The precision was undeniable. The odds of identical repetition from natural sources across separate observation periods are astronomically small. When the data reached Harvard's Galileo project servers, Avi Loeb's team quietly reopened an old comparison file, the 1977 WOW signal. The overlap was eerie, frequency identical, duration nearly identical, signal-to-noise ratio nearly identical. The 2025 pulse differed only in modulation depth. It was slightly more structured, showing faint oscillations as if encoding phase shifts. No official agency commented. Within hours, the raw data was classified by the National Science Foundation under the pretext of data integrity review. But a copy of the spectrum leaked anyway, spreading through encrypted astronomy channels worldwide. Researchers in Japan, India, and France confirmed that the signature couldn't be from Earth-based satellites or ionospheric reflection. Its Doppler drift corresponded precisely to an object traveling at 54 km/s, the same measured velocity of 3I Atlas after deceleration. That alignment was the turning point. Suddenly, every network trained on the same frequency. The SETI Institute reactivated deep beam arrays that had been dormant for years. China's FAST telescope scheduled emergency observation windows. The European Space Agency ordered additional telemetry time from its deep space antenna in Taparos, Spain. The instructions were simple: continuous monitoring from 1419.88 to 1420.6 MHz 24 hours a day. Then for nearly 3 days, nothing, just static until the night of November 11th when the pulse returned stronger, longer 81 seconds this time. The same 3 amplitude peaks, Same 47-second spacing, but with something new. A faint secondary carrier tone rising from 1420.405 to 1420.416 MHz, as if sweeping slowly upward. It wasn't random noise. It was deliberate frequency drift, smooth and precise, too coherent for natural emission. Astrophysicists debated through the night. Was this Doppler shift, instrument drift, or active modulation? The debate split laboratories worldwide. Some insisted it was solar reflection of Earth signals bouncing off charged dust, others that it was an intentional beacon. But the power output told another story. Based on signal strength and distance, the emission source had to radiate at least 20 GW isotropic, matching the theoretical energy readings of the 9 companion objects. That correlation reignited a hypothesis abandoned weeks earlier that each companion was a transmission node, part of a phased array designed to focus energy directionally like interstellar radar. The energy burst before perihelion could have been alignment tests. The current pulse's active transmission. Governments moved fast within hours of the 11th of November detection. U.S. Strategic Command restricted public access to multiple radio observatories under temporary coordination measures. A similar order followed from China's Ministry of Science. Yet, leaked voice memos from inside the Allen telescope array hinted that the 11th of November pulse carried more than just energy. It carried structure. Analysts described it as amplitude-coded binary, a pattern alternating in a way that couldn't be statistical randomness. Some even claimed the ratios resemble prime sequences 2, 3, 5, 7, 11, though no full decoding has been verified. NASA, for its part, maintains official silence. Their only public comment came through a short line on November 12th. No credible evidence of artificial origin detected. Privately, however, insiders admit that the AY's DSN antennas have recorded 4 separate pings at 1,420 MHz, each stronger than the last, all coming from the same spatial vector. Whether the signal originates from 3I Atlas itself or from reflections off the solar plasma remains under investigation. For now, all interpretations remain theoretical. Yet the repetition, the 47-second rhythm, has become the most debated number in science, too slow for rotational modulation, too exact for chaos, too familiar for coincidence. If the pattern continues, the next pulse should occur between November 15th and 16th, depending on trajectory. Telescopes across the world are already synchronized for the attempt. In this global watch, something has changed in the scientific tone. The skepticism remains, but beneath it runs quiet anticipation, a sense that the question has shifted from if to what. No one calls it a message yet, but everyone everywhere is listening. Because when an interstellar object emits at the universal hydrogen frequency, the one line of radio known across the cosmos, it isn't just speaking physics. It's speaking the language of intelligence itself. And if 3I Atlas continues to pulse in that rhythm, then we are no longer observers of a silent rock crossing our sky. We are participants in a dialogue that began long before hum. By November the 16th, 2025, the Global Observation Network was operating in near constant coordination. Every major dish and space-borne antenna pointed toward the same narrow region of the sky, where 3 Atlas was expected to reappear from behind the solar limb. The world's best instruments fast in China, the Very Large Array in New Mexico, ALMA in Chile, had all synchronized to the hydrogen line frequency. Scientists were not waiting for light this time. They were waiting for rhythm. And at 219 UTC, it came. The next pulse arrived right on schedule, 47 seconds apart, 3 peaks again, lasting 82 seconds. Only this time there was something new. A fourth pulse followed 20 minutes later, weaker but unmistakable. A deviation, intentional or otherwise, breaking the perfect triad that had defined every transmission before. When the signal was analyzed, the additional peak carried a shifted phase, almost a harmonic echo. Whatever was producing it wasn't fading, it was evolving it. While radio teams celebrated the catch, optical telescopes captured the first faint light curve of 3I Atlas emerging from the solar glare. What they saw changed everything. The object was no longer a single elongated mass surrounded by smaller companions. It was a formation, 10 discrete sources now forming a geometric configuration that analysts later described as a rotating plane of symmetry. Instead of following a linear path, the companions had repositioned themselves into what looked like a circular lattice, 9 points orbiting one central hub. The distance between them was identical across all vectors. It wasn't random, it was patented. The Chilean observatory reported that, as the cluster moved further from the solar glare, its reflective signature increased by 12% per hour. Not because it was brightening, but because the objects were aligning flat against sunlight, reflecting maximum surface area at the same angle. That kind of coordination defies every known natural process. There is no mechanism gravitational, magnetic, or radiative that can align separate bodies that precisely over millions of kilom without structural connection or active control. At that same hour, JPL received a short-lived telemetry glitch across the deep space network's node. A burst of interference sweeping between 2.1 and 2.3 gigahertz, overlapping the hydrogen frequency's upper harmonics. It lasted 6 seconds and then vanished. The pattern matched an artificial frequency ramp, similar to what human spacecraft use for uplink testing. The engineers didn't comment publicly, but internally the file was labeled Active Transmitter Event. The combined data forced agencies to act. NASA, ESA, and CNSA, China's National Space Administration, issued a joint statement, the first of its kind in history, acknowledging that a consistent signal pattern of unknown origin had been detected and that further investigation was underway. The document didn't mention 3 Atlas by name, but the timing left a little doubt. For the first time, official channels were addressing what everyone already knew. Something beyond normal astrophysics was taking place. Avi's team released an independent update that same night using triangulated timestamps from Chile and California. They confirmed that the signal originated from within the 3 Atlas formation's current coordinates, not from solar reflection or background interference. The team's conclusion was careful, almost painfully so. The emission source displays frequency stability and timing precision, consistent with an engineered origin. That was as close as any mainstream scientist had ever come to calling something extraterrestrial. Meanwhile, a new problem emerged. The object's velocity had changed again. Not slowed this time, but accelerated, gaining nearly 6 km/s over 24 hours, placing it ahead of its predicted position. Such acceleration cannot result from solar pressure or outgassing. The object was moving away from the sun. It was in effect performing the reverse of its previous maneuver. The exact deceleration before perihelion was now mirrored by acceleration after it. An almost perfect symmetry. The implication was chilling. The object had not simply survived perihelion. It had used it. By entering near the sun, it may have absorbed or redirected energy to execute a course correction like a gravity-assisted burn. The motion followed a curve leading outward toward Jupiter, matching the earlier projections that suggested a potential slingshot maneuver. As these readings circulated among scientific teams, governments quietly increased monitoring of the Jupiter system. The ESA's Juke mission, already en route to the Jovian moons, was instructed to adjust its sensor arrays for long-range tracking. At the same time, the U.S. Space Command issued a classified bulletin referencing possible inbound high-energy objects of non-gravitational trajectory origin. The wording was cautious but unmistakable for the public. None of this was visible. Official news networks framed the event as radio anomalies coinciding with solar interference. Yet, online observatories and amateur astronomers had already shared the raw data. Within hours, the story spread. 3 Atlas is back, and it's changing direction. In scientific circles, the debate shifted again from what 3I Atlas is to what it's doing. The regularity of the hydrogen pulses now looked less like a beacon and more like telemetry, a heartbeat signal, the kind spacecraft used to confirm operational stability. If that's true, then the formation isn't just a collection of fragments. It's a coordinated system. As the data poured in, analysts began to notice a deeper pattern. The timing of each pulse, when plotted over time, formed a curve of decreasing intervals, each 0.02 seconds shorter than the last, as if counting down to synchronization. No one could explain why, but the sequence pointed toward a single temporal convergence, December 6th, the same date Atlas was predicted to reach full visibility beyond the Sun. Whether coincidence or design, it means one thing. Whatever is guiding this formation is preparing for something. Every movement, every signal, every shift in trajectory is leading to that date. And tonight, as observatories around the world continue to record the faint rhythmic pulse echoing through the hydrogen line, scientists face a question none of them are trained to answer. If this is a countdown, what happens when it reaches zero? Entity existed finally audible through the noise of a burning star. By November the 20th, the data was no longer subtle. The 3 Atlas formation was accelerating on a direct vector toward Jupiter, maintaining its perfect geometry. 9 outer bodies revolving around one luminous core. The pattern now covered a spatial diameter of nearly 50,000 km, rotating once every 9 hours with mechanical precision. Even through atmospheric distortion, the rhythmic changes in brightness were too clean to be coincidence. The Chilean and South African observatories confirmed it independently. The formation was maintaining angular momentum like a rigid structure. That detail alone shook the astronomical community. A natural cluster would drift, its fragments gradually dispersing under gravitational shearing. Yet every one of 3 Atlas's companions remained in lockstep motion, each maintaining exact spacing as if tethered by invisible lines. It was behaving less like a group of rocks, more like an engineered array. The latest projections from JPL placed its trajectory intersecting Jupiter's orbital path on March 7, 2026. The margin of error was less than 0.01 astronomical unit. That precision is beyond any random gravitational capture. To reach that level of accuracy, the formation would have had to perform at least 3 controlled adjustments since Perihelion, each one perfectly timed, each one too subtle for human detection until now. Meanwhile, the hydrogen line pulses continued every 47 seconds without fail. The signal repeated, 3 bursts then silence. But as the object moved farther from the Sun, the amplitude rose. What had once been a faint whisper across the noise floor was now a clear, structured pattern, strong enough to saturate several receiving arrays. Some researchers proposed that the pulses were directional, rotating like a beacon. When Earth aligned with the emission cone, the signal peaked, and when it drifted out, it faded. The data supported this. On November 18th, when Earth passed slightly behind the object's line of motion, the signal dropped by half. 2 days later, it returned at full strength. The implication: the formation was transmitting in a controlled arc, scanning the solar system like radar. Inside NASA Deep Space Network, the atmosphere had turned tense. Engineers began tracking tiny fluctuations in the time delay between pulses, noting that the gap shortened by exactly 1 millisecond per cycle. A pattern that precise could only mean one of two things: a countdown or calibration. Either way, something intelligent was refining its timing. On November 22nd, ESA's Solar System Division confirmed another anomaly. High-resolution infrared mapping detected temperature gradients across the outer nodes, heat signatures rising and falling in a synchronized wave, each separated by 47 seconds, the same period as the hydrogen pulses. Whatever the formation was doing, it was coordinated across light years of physics and logic. The possibility that the pulses were controlling the formation, rather than merely transmitting, became impossible to ignore. The signals could be command instructions, maintaining rotation and alignment through synchronized bursts of internal power. Avi's team at Harvard published a technical note that same day cautiously titled Non-Gravitational Synchronization in Interstellar Objects. It read like history disguised as mathematics. Their conclusion: no natural mechanism accounts for sustained geometric stability coupled with coherent energy modulation. The most parsimonious explanation is active station keeping. It was the closest anyone had come to declaring it artificial, without saying the word. And yet, even as the academic world reeled, the geopolitical one was already moving. Within hours of the Harvard note, the U.S. Space Command issued a notice to NORAD and allied networks to elevate continuous orbital tracking of non-terrestrial formations. In plain terms, they had begun military monitoring. China responded in kind, activating its early warning radar network. Russia followed the next day. The world had entered silent alert, a phase of guarded cooperation between rival nations, who suddenly faced something bigger than rivalry itself. Behind the public calm, private observatories leaked what they could. The chilly data now showed the formation emitting faint bursts of charged particles visible as microscopic distortions in magnetic field readings. Each burst corresponded exactly with one of the radio pulses. For 7 minutes after each sequence, the field around the formation shimmered as if ionized gas were being manipulated into controlled streams. In human engineering terms, that would be equivalent to micro-thrusters adjusting position, something designed to maintain precision in deep space. Then came the final revelation, a pattern buried in the timing intervals. Data analysts at the European Southern Observatory plotted 1,200 recorded pulses over the last 3 weeks. When mapped as binary peaks and troughs, the pattern formed a repeating sequence: 2, 3, 5, 7, 11, 13, 17, 19. The first 8 prime numbers, no one could explain why. Statistically, the odds of that order emerging randomly from a natural modulation are so small they might as well be zero. For the scientists who have followed this object since its discovery, the message is simple but staggering. The formation isn't random, and its signals aren't accidental. Whether it's a communication, a calibration, or something entirely beyond human logic, it follows structure, mathematical intent. And mathematics is the only universal language across the cosmos. Now, all projections converge on a single event: the Jupiter flyby. If the formation performs another velocity change as it approaches the planet, its destination will be confirmed not as an escape into interstellar space, but as insertion into a stable orbit within our solar system. That would mean it's here to stay. No one says that out loud yet. Not in conferences, not in press releases, but the equations are already whispering it. The object is moving with purpose, transmitting with precision, and aligning with a gravitational anchor point that humans have used for a century as the gateway to deep space. It is following the same path we would if we were arriving. And as it continues to accelerate toward Jupiter, one quiet truth has settled among those who study it. The story of 3 Atlas no longer belongs to astronomy. It belongs to history. Because, if what's approaching that giant world is what it appears to be, then for the first time in recorded existence, Earth is no longer the only civilization operating inside our solar system. December 1st, 2025. The formation has crossed Mars's orbital path and is now deep within the inner boundary of the asteroid belt. The gap between 3I Atlas and Jupiter is closing faster than any model predicted. Its current velocity is 61 km/s.6, above what orbital mechanics should allow after perihelion. No known gravitational assist explains that gain. It's as though the object accelerated from within, expelling force that left no visible trace. Every major space agency now tracks the event under different code names. NASA calls it Object 31A cluster. ESA uses ecliptic array, and China simply refers to it as Target 0. None of them publicly acknowledge the radio pulses, but every deep space antenna continues to listen. The hydrogen line signals have changed again. The pattern that once repeated every 47 seconds has tightened to 41.8, exactly 89% of the original period. The shift isn't random. It follows a decaying exponential curve that models perfectly onto a countdown approaching 0 on December the 6th, 2025, 2311 UTC. The time when 3I Atlas will pass behind Jupiter's shadow. If that date holds, then the countdown and the maneuver converge on the same moment. A convergence that statistically cannot be accidental. Astronomers across the world are racing to prepare. The Hubble and Webb telescopes have both been retasked for emergency observation of the Jovian system. Even the Lunar Gateway platform, still in limited operation, has pivoted its sensors toward Jupiter's limb to record whatever occurs. The atmosphere in every control room feels unreal. Half science, half waiting for something no one has words for. In leaked emails from ESA's control center, one engineer wrote, "It's behaving like it knows the geometry of our senses." He was referring to the way the formation's brightest node now angles itself precisely toward Earth during each signal burst, reflecting sunlight in micro flashes that align with telescope schedules. Out of 10 observation windows, 9 have captured those glints within seconds of predicted exposure. It's as if the object wants to be seen, just not too clearly. Spectral analysis confirms that its reflectivity no longer matches any natural surface. The readings show metallic ratios, nickel, chromium, silicon carbide, arranged in smooth gradients that suggest layered construction. There are no randomized mineral bands, no signs of fracturing. It is built. Meanwhile, the magnetic field around Jupiter is already responding. Since November 28th, the Juno spacecraft has recorded transient fluctuations, short bursts of charged particles radiating outward in pulses that mirror the 41.8-second rhythm. These events originate tens of millions of km ahead of Jupiter, directly along the incoming trajectory of 3I Atlas. Juno's magnetometer team has privately concluded that external coherent fields are modulating the flux. That's the cautious way of saying something is deliberately interacting with Jupiter's magnetosphere. On the ground, that conclusion is splitting the scientific community in two. The conservative camp insists the anomaly is a solar wind harmonics amplified by the approaching body's metallic content. The opposing view, quietly gaining momentum, is that the formation is testing Jupiter's field, mapping its strength the way a probe would before entering orbit. The pattern matches what human spacecraft perform during approach: electromagnetic sweeps for radiation belts and particle density. The implications are obvious yet too extraordinary to declare, so official language stays neutral, investigating unmodeled magnetospheric interactions. But in private briefings, the tone is changing. Multiple agencies now refer to the formation not as a comet or an asteroid, but as a vehicle. At Harvard, Avi's group released a closed circulation memo summarizing current data. It states that the synchronized deceleration at perihelion, the coordinated acceleration post-perihelion, and the formation's consistent thermal control exceed natural object behavior by at least 4 orders of magnitude. The final paragraph is short, almost hesitant. We are observing intentional orbital dynamics. Even skeptics are running out of natural explanations. Mikioku, who has defended the magnetic coupling theory for months, admitted in a late-night interview if it turns at Jupiter, "I'm done calling it a comet." The world watches the same countdown now. Every 41.8 seconds, the hydrogen line pulses echo through space, steady and unwavering. The newest measurements show minute frequency drifts, upward shifts of 0.003 MHz/hour, consistent with Doppler compression as the formation accelerates. And yet there is modulation layered over it, a faint secondary signal amplitude keyed rising and falling in binary intervals. When decoded, it forms repeating prime sequences separated by the Fibonacci ratio. Mathematics again, the universal constant of intelligence. Civil agencies have begun quiet contingency planning. The United Nations Subcommittee on Outer Space Policy held a closed meeting titled Contact Protocol Review. No statements followed, but insiders confirmed that representatives from every major power attended, including military observers. The subject was not theoretical contact. It was how to respond if communication occurs within the solar system. The public still hears nothing. The official story remains a comet exhibiting magnetic anomalies, but amateur observers are recording the same pulses with home-built receivers, posting spectrograms online before they are taken down. People are listening to the countdown without knowing it's a countdown. Inside mission control, the tone is shifted from excitement to restraint. Engineers speak in short sentences. Analysts avoid adjectives. Everyone understands the stakes. If the formation performs a controlled braking maneuver behind Jupiter, then every assumption about human isolation in the universe collapses overnight. And if the pulses cease, replaced by silence, that too will be an answer, one the world may not be ready to hear. For now, the only certainty is the timeline. 4 days remain until December the 6th. When 3 Atlas slips behind Jupiter's shadow, every telescope, every dish, every sensor humanity possesses will be pointed at that single patch of sky. If it disappears, the story ends. If it acts, the story begins. Somewhere between those outcomes lies the truth. Waiting in the cold, dark beyond the planet's glow, where something ancient and deliberate is preparing its next move. And the human race stands on the edge of the greatest silence it has ever tried to measure. December the 6th, 2025, 2311 UTC. For the first time since its discovery, 3I Atlas is invisible to every optical instrument on Earth. It has entered Jupiter's shadow, the region of complete solar occlusion where even reflected light cannot reach. In that darkness, the countdown ends. At exactly the predicted moment, the hydrogen line pulses stop. After months of perfect precision, the 41.8-second rhythm vanishes mid-cycle. No fading, no interference, just absence. For 32 seconds, the receivers at FAST, ALMA, and the Allen array record total silence. Then at 2312 UTC, the signal returns, but it's different. No longer 3 peaks or 4. It's a single continuous tone, unwavering, lasting 1 minute and 21 seconds. Then it stops again. Across observatories, scientists stare at their screens in disbelief. The tone wasn't noise. It was pure coherent emission. No sidebands, no static, no drift. The kind of signal produced only by active frequency locking, like an instrument deliberately tuning itself. And then something else happens. For the first time, Jupiter's magnetosphere responds in kind. The Juno spacecraft, still on its elliptical orbit around the gas giant, detects a burst of radiation from the planet's upper atmosphere, identical in timing to the tone. The energy level spikes for 8 seconds, forming a spiral pattern across magnetic field lines. No known natural process can synchronize emissions between two bodies separated by tens of millions of kilom. The simplest interpretation is also the most unsettling. Something interacted with Jupiter. The telemetry feeds in Houston and Darmstadt light up with contradictions. Juno's magnetometer readings surge, but its cameras show nothing unusual. Jupiter's auroras flare, then subside. It's as though a wave of energy passed through the field, invisible but structured. Minutes later, Juno's radiation detectors pick up a transient burst, a directed beam of high-energy particles traveling away from the planet along a vector that perfectly matches 3I Atlas's trajectory before shadow entry. In the same instant, the formation's coordinates vanish from radar. To outside observers, it looks like disappearance, but to those reading the data live, it looks like departure. Within an hour, signals from the Deep Space Network confirm that 10 separate objects, the central body and 9 companions, are no longer where they should be. They haven't fragmented. They haven't slowed. They're simply gone. Every model tracing their momentum shows the same result: an instantaneous acceleration of at least 0.15 c, 15% the speed of light. Too fast for detection, too controlled for explosion. The universe offers no known mechanism for such movement, unless, of course, it was intended. NASA immediately suspends all live telemetry feeds. The official explanation: data corruption from high solar interference, but every scientist on those networks knows the timing is too precise. The blackout began the second the tone ended, the instant the formation left Jupiter's shadow. Inside the Galileo Project's Cambridge office, Avi Loeb convenes an emergency call with international colleagues. His first words, later paraphrased by one participant, are simple: "We just watched something leave." For the next 6 hours, teams across the world reanalyze their data. No one can reconstruct a stable trajectory. The only thing they agree on is direction. Outbound, angled 37 degrees above the ecliptic, pointed toward interstellar space. Meanwhile, Jupiter's magnetosphere continues to ripple. The shock wave reaches Io, then Ganymede, then fades. Juno's instruments detect lingering electromagnetic harmonics. Low-frequency pulses repeating every 13.7 minutes, too deep for human hearing, but strong enough to be felt as vibration in the probe's onboard sensors. The wave diminishes gradually like a bell struck in the dark. By dawn on December the 7th, the scientific world splits into 2 camps. One claims the event was a catastrophic data failure. The other believes humanity has witnessed propulsion technology beyond comprehension. A few go further, suggesting the formation used Jupiter as a launch node, converting its magnetic energy into thrust. It sounds impossible, but the numbers fit too well to ignore. No debris, no plume, no detonation, just a pulse, a flare, and an empty sky. Around the world, the public hears only fragments of the story. Unusual radio silence, temporary loss of observation, data anomaly. But the amateur astronomers who track the object from the beginning know better. Their infrared scopes confirm what official channels refuse to say. The coordinates where 3I Atlas should be are clean. Space itself looks freshly brushed, as though the formation erased its presence completely. Theories multiply in the silence. Some say the formation entered a higher dimensional transfer, folding its trajectory through gravitational resonance. Others believe it used Jupiter's magnetic field as a catapult. But one fact remains: everything that happened followed a pattern, and the pattern ended only after the final signal. The tone, the acceleration, the disappearance. No one knows if it was a message or an act of departure. But a few hours after the event, the hydrogen frequency at 1420.405 MHz flickers one last time. A single narrow band pulse barely detectable above background noise. It lasts 4.7 seconds. Its waveform carries no structure, no modulation, just a faint descending echo. Some interpret it as residual energy, others as something else entirely, a sign-off. In the following days, agencies issue joint statements confirming that 3II Atlas is no longer detectable by any known instrument. The data becomes classified under the International Non-Terrestrial Phenomena Accord, signed in haste during the night of December 7th. The event's details are sealed. Even within the scientific community, access requires top-level clearance. The official public record concludes simply 3I Atlas disintegrated following perihelion passage. No further observation possible. But the scientists who watch the data live know better. They saw order, not chaos. They saw symmetry, not decay. They saw movement with intent. And somewhere beyond Jupiter's orbit, far past the reach of human instruments, 10 silent travelers are gone, leaving behind only a mathematical rhythm and a question that will haunt science for centuries. Did we just witness a departure or a return? December the 8th, 2025. 2 days since the disappearance. 2 days since the last tone. The one that ended the most closely observed celestial event in history. The world has returned to silence, but the instruments haven't stopped listening. And in that silence, something faint remains. At first, it looked like background noise. The Parkes Observatory in Australia reported a lingering oscillation at 2.7 microelvin above the cosmic microwave background, a fluctuation too small to notice under normal conditions. But when cross-keyed against frequency, it matched the exact harmonics of 1420.405 MHz, the hydrogen line. It wasn't a pulse this time, but a residue, a ghost frequency echoing through the radio spectrum like the hum left behind when an amplifier shuts off. Scientists call it an afterglow, the last footprint of an emission so powerful it bent the local plasma field. That's what the data shows: a ring of ionized particles expanding outward from the region where 3 Atlas vanished, spreading like ripples across Jupiter's magnetosphere. The wavefront is still detectable, moving at nearly 800 km/s. It's weak now, but perfectly symmetrical, a hollow shell of energy expanding in silence. No one knows what caused it. Some believe it's a byproduct of the acceleration event, a residual field from whatever mechanism propelled the formation beyond measurable velocity. Others suggest it's a transmission artifact, a kind of beacon left behind intentionally. Its expansion rate, if plotted backward, traces to a single moment, the 81-second tone on December 6th. The data implies that the tone wasn't just a signal. It was a trigger. By December 8th, every major observatory has turned toward Jupiter. The gas giant's atmosphere is calm again. The aurora is fading to normal intensity. But the planet's radiation belts now carry a repeating distortion, a low-frequency hum undetectable by human ears, but persistent across multiple probes. The pattern repeats every 13 minutes, decaying exponentially, as if something vast and invisible is still ringing. In the days that follow, rumors begin to spread among those who had direct access to the data feeds. Some claim that just before the final acceleration, one of the formation's smaller nodes emitted a secondary burst at 1665 MHz, a frequency associated with hydroxyl mazes, the chemical signature of water. If true, it would mean the signal wasn't purely electromagnetic. It interacted with matter, possibly altering Jupiter's upper atmosphere. No official statement confirms this, but the timing aligns. One final chemical trace, then total silence. Inside mission control centers, fatigue has replaced awe. Teams have slept little in the past 72 hours. They reprocess the same data sets, running correlation after correlation, trying to find a rational explanation. The equations work, but only if you assume control. The deceleration, the acceleration, the precision of the hydrogen line transmission, the use of Jupiter's field. Each one follows engineering logic, and if engineering logic applies, then intention must too. On December 9th, a confidential memo circulates through the International Astronomical Union. Its language is clinical, almost detached, but its conclusion is not. It states, the data collected between October 12th and December 7th, 2025, describes a phenomenon consistent with directed energy propulsion and coherent communication. Natural explanations insufficient. The document is not for public release, but it leaks anyway, and by morning, every major science outlet in the world runs the same headline. Atlas leaves the solar system. The phrase isn't technically accurate. The formation's vector suggests it's not leaving directly. It's following a curve that will take it above the ecliptic, passing near the orbit of Saturn within 8 months. Then its path becomes uncertain, too steep to remain bound, but not steep enough for total escape. Some speculate it's waiting or repositioning. And then another discovery. Deep within the raw telemetry files from the December 6th event, a small anomaly appears. A modulation within the 1-minute tone, nearly imperceptible, buried in the carrier wave. When enhanced, the modulation resolves into a binary structure. 2 long intervals followed by 3 short, then 571. The first 5 prime numbers, the same sequence that defined the pulses before departure. A signature repeated one last time, hidden within the farewell. It's not a message humans can decode, but its intent is clear. Structure, precision, acknowledgement, the signature of design. For the first time in history, human science must describe an event without language to contain it. Was it departure or demonstration? Was 3I Atlas a probe, a vessel, or something beyond both? The data ends, but the question does not, because what remains, the afterglow, the harmonics, the rhythm in the background radiation suggests that the object didn't just leave, it adjusted. By December 10th, one final transmission from Juno reaches Earth. In its last magnetometer sweep before data loss, the spacecraft recorded a slow, rhythmic modulation, too low frequency for analysis, but persistent enough to be real. It fades gradually as Juno drifts behind Jupiter's radiation belt. The last note in its data log reads, field still oscillating, source indeterminate, and then nothing. Silence again, but this time the silence feels different. Not empty, but waiting. As if the cosmos itself is holding its breath the way it does after something immense has passed through. Because maybe 3I Atlas wasn't a visitor at all. Maybe it was a reminder, a demonstration of what intelligence looks like when it moves through darkness quietly, precisely, and with purpose. And somewhere far beyond the orbit of Jupiter, that purpose continues, accelerating into the night, leaving behind only the faint memory of a signal that once reached back and was heard. December the 15th, 2025, 9 days since the disappearance, the sky has gone quiet again. Not empty, just heavier somehow. Every telescope that once watched 3 Atlas now stares into coordinates filled with nothing but background starlight. The formation is gone, but the instruments keep recording. They always do, even when there's nothing left to see. In that absence, the data itself has begun to shift. Analysts at the European Space Operations Center noticed faint distortions in the radio noise between 1420 and 1420.4 MHz. Not pulses, not signals, but periodic voids in the spectrum. Each gap lasts 47 seconds, the same interval that once marked the heartbeat of 3I Atlas. It's as if the frequency itself remembers what passed through it. Not radiation, but an absence of it. A memory encoded in silence. Astronomers now call it the Atlas Echo. It's not confirmed, of course. The gaps could be interference, power fluctuations, atmospheric scatter. But when 10 observatories across 4 continents detect the same rhythm, the word coincidence begins to lose meaning. And yet, no one talks about it publicly. Not anymore. The event has already been sealed behind layers of policy and protocol. Classified briefings circulate under euphemisms. Transient frequency retention, ionized field memory, non-local energy decay. But every scientist who has seen the data knows what it is. They just can't say it out loud. The world has moved on. News outlets call the story closed. The comet that broke the laws of physics has simply faded into history, filed away beside Oumuamua and TUI Borisov as another curiosity. But the people who watched it vanish can't let go. They still meet quietly, trading encrypted files, still plotting trajectories that lead nowhere. They speak less like astronomers now and more like witnesses, because the numbers refuse to die. Avi's private logbook notes something extraordinary. 2 weeks after the disappearance, the cosmic microwave background shows a localized anisotropy, a faint directional excess in energy flux precisely aligned with the departure vector of 3I Atlas. It's not strong enough to register as a new source, but it's there. An imperceptible line pointing outward from Jupiter's orbit. It's moving too slowly, predictably, as though the universe itself had been disturbed, and the disturbance is still traveling through it. Meanwhile, Juno continues to relay residual readings from Jupiter's magnetosphere. The magnetic harmonics that began after the departure have not faded. They've stabilized, now repeating every 13.701 minutes with machine-like regularity. The amplitude is constant, the phase locked to the planet's rotation. The field is humming, and no one knows why. A report leaked from NASA Goddard Space Flight Center describes the phenomenon as coherent induced oscillation, but the data doesn't fit any natural resonance. Jupiter shouldn't hum like this. It's too steady, too deliberate. The simplest explanation is the most unspoken one, that the event left something behind. Not debris, not an artifact, just a pattern. In March 2026, when the shock wave reaches Saturn's outer magnetosphere, the Cassini-2 probe registers the same harmonic pattern. The frequency has stretched slightly from 13.701 to 14.02002 minutes, as if the wave is adapting to each planet's magnetic rhythm. The pattern isn't dissipating. It's propagating, moving outward planet to planet like a slow, invisible message crossing the solar system. By then, no one publicly connects it to 3 Atlas. The official records have buried the name. But among the people who know, there's a quiet consensus forming. The object didn't just pass through our system. It tuned it. It left the solar system humming at a frequency that matches the rhythm of hydrogen itself. 1420.405 megahertz, the language of the cosmos. If that's true, then the signal never ended. It just changed medium. It moved from transmission to resonance, from sound to structure. The way a note plucked once from a string can keep vibrating through air long after the player has gone. In a small office in Cambridge, Lowe writes one final entry into his private notebook. It isn't a conclusion or a theory, just a single line. They didn't come to speak. They came to calibrate. And beyond Jupiter's orbit, somewhere in the cold between stars, 10 silent travelers continue their journey, unseen, untraceable, but not gone. The void behind them sings in intervals of 47 seconds. A lullaby written in physics and left for anyone who learns to listen. Maybe one day something else will answer. Maybe it already has. But for now, all that remains is the echo, faint, mathematical, and perfectly timed, whispering through the hydrogen sea that fills our universe. The sound of departure, still resonating long after the light has gone. April 2026. 4 months since the disappearance. The story has vanished from headlines, but the data has not. Deep space sensors continue to record irregularities, tiny fluctuations in the background radiation that rise and fall like breath. They occur every 47 seconds, not strong enough to be called signals, not random enough to be dismissed. The International Data Consortium keeps them buried in encrypted archives, labeled atmospheric refraction variants. But among those still watching, the physicists, the engineers, the ones who stayed long after the rest moved on, the pattern has earned a new name, the calibration. The first hint came from an unlikely source, an old probe, Voyager 2, still transmitting weak telemetry from beyond 22 billion km. On March 29th, it registered a brief surge, an uptick in plasma wave amplitude that lasted exactly 47 seconds, repeated 3 times, then faded. The direction of origin matched the same vector 3I Atlas had taken after Jupiter. It couldn't have been coincidence. Voyager's instruments aren't powerful enough to record fine detail, but they measure rhythm, and rhythm is what returned. The signal pattern looked identical to the one first observed in late October 2025, down to the microsecond. Something was still emitting somewhere beyond the helioper, the threshold where the sun's influence ends. No one announces this publicly. The findings circulate quietly through private networks, past encoded emails and whispered conference calls. Everyone who studies it agrees on one unsettling conclusion. The pulses are not fading with distance. They are stabilizing, as if locking the system into a new baseline. The solar wind itself now carries a rhythmic density fluctuation. Small, nearly imperceptible but measurable. Our star, it seems, has been tuned. At first, researchers think it's instrumentation drift. But then, on April 7th, the same rhythm appears in data from the Solar and Heliospheric Observatory, an entirely separate satellite still inside the Sun's gravitational domain. 2 machines billions of kilometers apart recording the same periodic voids. The effect is global. The calibration is everywhere. Inside mission control, analysts begin running long-term models. They find something even stranger. The periodicity of 47 seconds is not constant. It's subtly shortening. By April 15th, it's 46.9. By April 18th, 46.7. Extrapolated forward, the countdown leads to June 3rd, 2026. At that rate, the rhythm converges on 0, a point of synchronization where the pulse would no longer be periodic, but continuous. In physics, that would mean one thing: resonance. A system perfectly aligned with its own oscillation, vibrating in equilibrium. Resonance is power. It's stability, but it's also control. Governments take the data seriously, but no agency claims responsibility for analysis. The UN's Non-Terrestrial Committee issues a single line in its April memorandum. Monitoring post-event magnetospheric stabilization continues. No public advisory warranted the phrase post-event quietly enters official vocabulary, the way euphemisms always do when science meets fear. Meanwhile, on the outskirts of the scientific world, independent radio operators begin to pick up faint harmonics. Using repurposed SCTI dishes and custom software, they isolate background noise from deep space recordings and run the spectra through compression filters. The result is eerie subsonic hums that pulse in perfect 47-second intervals. When sped up into audible range, they sound like a slow heartbeat wrapped in static. For weeks, no one dares to call it communication. But in late April, one team from Kyoto University overlays the pulses onto planetary magnetic field data and discovers alignment. Each beat coincides with small oscillations in Jupiter's magnetosphere. The pattern is not arbitrary. It's relational, as if the source beyond the helip is still connected to Jupiter, still maintaining calibration between the planet and itself. And this is where the theory changes. Perhaps 3I Atlas wasn't a visitor. Perhaps it was a mechanism, a system designed not to observe, but to adjust, to synchronize celestial fields to a shared frequency, one woven into the hydrogen spectrum that defines all matter. If that's true, then what happened on December 6th was not an ending. It was activation. The sky is quiet now, but too precise to be silent. Every satellite reports the same residual hum in its magnetometers. A uniform baseline noise once thought to be cosmic static. It isn't static anymore. It's organized. No one can explain how the effect sustains without input. Energy should dissipate. Patterns should decay. Yet the data remains clean, rhythmic, self-correcting, as if something unseen continues to fine-tune it from afar. On April 30th, a final set of readings comes from Voyager 2 before transmission fades again. The probe's aging instruments record one last anomaly. A single narrowband pulse at 1420.405 MHz, lasting exactly 4.7 seconds, the same duration as the goodbye tone 4 months earlier. The difference now is amplitude. Stronger, sharper, closer. It came from ahead of the probe, not behind. Something waiting in the dark beyond the helipores, responding to the rhythm it left behind. The calibration holds. The solar system hums in unison, and the instruments keep listening, caught between physics and prophecy, wondering whether they are recording the universe settling or beginning again. Because whatever 3 Atlas did out there, it hasn't stopped. It's just continuing somewhere we can't yet see. October 29th, 2025. For months, the world has been watching, waiting for this moment, the point of closest approach, when 3 Atlas disappears behind the sun. And now that moment has arrived. Every telescope on Earth is blind. Every signal is swallowed in the solar glare. The object, the 9 companions, the strange formation, all are gone from sight. What remains is silence. But it's the kind of silence that hums. The data leading up to this moment leaves us with more questions than answers. A formation of 10 bodies moving as one. Power readings that defy known thermodynamics. Observations cross-verified by instruments separated by oceans. And a timing so precise. A solar conjunction blackout coinciding with the maneuver window that even skeptics struggle to call it coincidence. NASA statements are careful, deliberate, almost scripted. The European Space Agency defers comment, citing post-conjunction verification. Independent observatories, once vocal online, have gone quiet, and in that quiet, a single truth remains. For the next 48 hours, no one can observe what's happening behind that wall of light. Not with telescopes, not with radar, not with anything we've built. This is the narrow margin, the blind passage where we either confirm the impossible or explain it away. When 3I Atlas re-emerges from behind the sun, it will tell us which world we live in. If the object appears where the orbital models predict, the natural theories hold. The fragments, the power readings, the geometry, all become noise, misunderstanding, coincidence. But if it reappears displaced, reconfigured, or accompanied by new signatures, if even one parameter falls outside prediction, then everything changes. Not just astronomy, but our entire sense of isolation in the universe. Because what we've been watching may not be random. It may not even be passive. Each anomaly, each perfect interval, Each impossible stability could be a single part of something larger, something coordinated, deliberate, waiting for this very moment of concealment to act unseen. A maneuver hidden behind a star. Until we see what emerges, the story remains suspended between two possibilities. Either nature is stranger than our equations can admit, or someone else has been writing the laws we've been trying to read. The sun will turn, the shadow will end, and when the light shifts, we'll finally know what crossed that invisible threshold. For now, the instruments hold their breath. The sky goes silent, and the line between physics and something else becomes thinner than it has ever been. We stand on that line tonight. Part 2. The Growing Mysteries, April through July 2025, Chapter 3. Thermal mysteries deepen as April arrived and spring settled over the northern hemisphere. 3. Atlas continued its relentless approach toward the sun. The object had now crossed into the inner asteroid belt, moving through regions where rocky bodies predominate over icy ones, where solar heating begins to have substantial effects on any volatile materials present on surfaces or in shallow subsurface layers. At its current distance of approximately 2.5 astronomical units, about 375 million kilometers from the Sun, 3 Atlas was receiving 4 times the solar energy per square meter that Earth does, enough to sublimate water ice exposed to direct sunlight, enough to drive cometary activity in objects with significant ice content. Dr. Yuki Tanaka had been monitoring 3 Atlas's thermal emission regularly since March, using the Subaru telescope's COMEX instrument whenever weather permitted and telescope scheduling allowed. Each observation session produced a spectrum showing how much infrared radiation the object emitted at different wavelengths between 8 and 25 micrometers. By comparing observations taken weeks apart, Tanaka could track how thermal properties evolved as solar heating increased with decreasing distance. The pattern that emerged over April and May troubled her deeply. The excess thermal emission she had tentatively identified in March was not only real but growing stronger. The object's surface temperature, determined from fitting blackbody curves to the thermal spectrum, was consistently higher than models predicted based on solar heating alone. And the excess wasn't constant. It was increasing faster than solar distance alone could explain. Tanaka constructed careful models of how 3 Atlas should warm as it approached the sun. She considered various surface compositions from pure rock to pure ice and everything between. She included effects of rotation, which causes surfaces to heat and cool cyclically as different areas face the sun. She accounted for thermal inertia, the tendency of materials to resist temperature changes, storing heat during the day and releasing it slowly at night. She incorporated sublimation cooling, the process by which evaporating ice carries heat away and keeps surfaces cooler than they would otherwise be. No combination of reasonable parameters could reproduce the observations. The models consistently predicted temperatures 10 to 20 Kelvin lower than what Tanaka measured. This might seem like a small discrepancy, but temperature measurement in astronomy is quite precise, and systematic errors had been carefully characterized and corrected for. The excess was real, reproducible, and growing. By early May, the thermal excess had increased to a point where it implied internal heat generation of approximately 800 kilowatts, double what she had tentatively estimated in March. This power output, while modest by human industrial standards, was extraordinary for a kilometer-scale object floating through space. Natural heat sources in asteroids and comets are limited and well understood. Radioactive decay generates heat in large bodies, but becomes negligible in small ones, because the amount of radioactive material scales with volume, while heat loss scales with surface area. Small bodies can't retain decay heat effectively, even if they somehow contained unusually high concentrations of radioactive elements. Chemical reactions might generate heat, but known chemical processes involving materials common in comets and asteroids don't produce power outputs approaching 800 kilowatts in kilometer-scale bodies. Crystallization of amorphous ice releases heat gradually over long timescales, far too slowly to explain Tanaka's observations. Reaction between water and reactive minerals can generate heat, but again not at rates sufficient to produce the measured thermal excess. Tidal heating, the process that keeps Jupiter's moon Io volcanic through gravitational flexing, requires strong external tidal forces that simply don't exist for an isolated object traveling through interplanetary space. The Sun's tidal forces at 2.50 are utterly negligible, incapable of producing measurable heating in a kilometer-scale body. Tanaka shared her findings with colleagues worldwide, sending detailed analysis and asking whether anyone could identify errors in her methodology or offer alternative explanations she hadn't considered. The response was a mixture of fascination and skepticism. Some researchers suggested instrument calibration issues, though Tanaka's careful work made this unlikely. Others proposed that the excess might result from active areas on the surface, regions where fresh ice was exposed and sublimating vigorously, creating localized hot spots that dominated the integrated thermal emission. But this explanation required implausibly high sublimation rates, rates that should produce visible cometary activity far exceeding what observations showed. Through June and into July, Tanaka continued monitoring while other observers joined the effort to characterize 3 atlases' thermal properties. Dr. Michael Chen at JPL used the Spitzer Space Telescope to obtain independent infrared measurements. Dr. Sarah Williams at the European Southern Observatory employed the VLT's Visier instrument. All observers found the same result: excess thermal emission beyond what solar heating alone could produce, emission that was growing stronger as the object approached the Sun. The thermal mystery became one of the primary topics of discussion at the summer meeting of the American Astronomical Society Division for Planetary Sciences. Tanaka presented her results in a talk attended by several hundred researchers. The response was vigorous debate. Could instrument calibration errors explain the discrepancy? Unlikely, given that multiple independent facilities found the same excess. Could some unknown property of interstellar material account for unusual thermal behavior? Possibly, but what property specifically? And why would it produce increasing power output as solar heating increased? One researcher suggested publicly what many were thinking privately. Perhaps 3 Atlas contained technology, devices that generated power for unknown purposes, heating that was a byproduct of whatever processes were running inside this object. The suggestion was met with uncomfortable silence, then criticism from those who argued that invoking technology was premature, that natural explanations surely existed even if we hadn't identified them yet. But the thermal mystery remained unresolved as July ended and August began. 3 Atlas was generating substantial internal heat that was increasing as it approached perihelion, heat whose source remained mysterious despite extensive analysis by some of the world's leading experts in thermal physics and planetary science. The anomaly had moved from tentative observation to confirmed phenomenon to genuine puzzle that resisted straightforward explanation through known natural processes. And the thermal mystery was not the only peculiarity growing more pronounced as observation continued through summer. The rotation stability persisted despite dramatically increasing solar heating that should have induced torques through asymmetric outgassing. The spectroscopic features continued evolving in discontinuous jumps rather than smooth progression. And soon, in mid-September, the most dramatic anomaly of all would be discovered: the 9 companions that would transform 3 Atlas from interesting puzzle into something that challenged fundamental assumptions about what was possible. But we are ahead of ourselves again. For now, in July, the thermal mystery stands as primary evidence that 3 Atlas was behaving strangely, generating heat through processes we couldn't identify, following patterns that didn't match any well-studied object in our solar system or any theoretical model of how interstellar objects should behave. The mystery invited speculation but resisted definitive conclusion, leaving researchers uncomfortable with ambiguity but unable to resolve it satisfactorily through available data and analysis. Rest now with this growing sense of mystery. Let the thermal puzzle join the rotation stability in your peaceful mind. Anomalies accumulating, patterns emerging that suggest something beyond ordinary cometary behavior. More revelations await as the story continues. More observations that will deepen the mystery rather than resolve it. More evidence that 3 Atlas was unlike anything we had encountered in our exploration of the solar system and beyond. Chapter 4. Spectroscopic puzzles the spectrum of an astronomical object. That detailed analysis of how it absorbs and emits light at different wavelengths serves as a fingerprint-revealing composition with remarkable specificity. Every element, every molecule, every mineral structure interacts with light in characteristic ways, absorbing certain wavelengths while reflecting or transmitting others. By examining the spectrum of reflected sunlight from an asteroid or comet, we can determine what materials compose its surface with more certainty than almost any other measurement technique, short of direct sampling. This is why spectroscopy has become central to planetary science. Without ever visiting an object, without sending spacecraft to touch its surface or return samples to Earth, we can identify the minerals present, detect water, ice, and other volatiles, recognize organic compounds, even infer how surfaces have been altered by space weathering, cosmic ray bombardment, and solar radiation over billions of years. Spectroscopy turns reflected light into chemical inventory, electromagnetic radiation into geological insight. For 3 Atlas, spectroscopic observations had begun immediately after discovery and continued regularly as the object approached the Sun. Dr. Elena Sokolov in Russia led one major spectroscopic campaign, obtaining high-quality spectra using the 6-meter BTA telescope roughly once per week when conditions permitted. Other observers worldwide contributed additional spectra using different instruments, building a dataset that tracked how 3 Atlas's spectroscopic properties evolved over time. The pattern that emerged through spring and summer was unlike anything Sokolov had seen in decades of studying comets and asteroids. The spectrum changed, not gradually and predictably as surfaces evolved under solar heating, but in discontinuous jumps, with new features appearing suddenly while other features disappeared or weakened dramatically. This behavior suggested that surface composition was changing not through smooth evolution, but through discrete events, as if different materials were being exposed or covered in ways that didn't follow standard models of cometary activity. In March, the spectrum had shown a mixture of features consistent with silicate minerals and water ice, a reasonable combination for a comet formed in the outer regions of a planetary system. By May, those silicate features had strengthened while the water-ice signatures had weakened, as if ice was sublimating away to expose rockier material beneath. This progression made sense and followed expected patterns. But then in early June, the spectrum suddenly showed strong features from organic compounds, complex carbonaceous molecules that hadn't been visible in earlier spectra. Where had these organics come from? Had they been hidden beneath surface ice that was now gone? Or had something about the observation changed to make previously invisible features suddenly detectable? Sokolov ruled out observational effects carefully. She verified that her instrument calibration remained stable, that no systematic errors could produce spurious features. She checked that changing viewing geometry as Earth and 3 Atlas moved in their orbits couldn't somehow create artificial spectral changes. Everything checked out. The changes were real properties of the object, not artifacts of measurement. More puzzlingly, in late June, the organic features weakened again, and new features appeared that Sokolov couldn't immediately identify. These absorption bands didn't match anything in the extensive spectroscopic databases she consulted, libraries containing spectra from thousands of minerals and compounds measured carefully in laboratory settings. She shared the mysterious spectrum with colleagues, asking if anyone recognized the features. Responses were puzzled. The absorption bands were sharp and well-defined, unlike the broad features typical of minerals. They looked more like molecular absorption lines, but they didn't match any common volatile compounds or organic molecules in the reference databases. One researcher suggested the features might result from exotic ice structures, clathrates where water molecules cage other compounds in specific geometric arrangements. Clathrates can have unusual spectroscopic properties, but clathrates form under specific pressure and temperature conditions, and it wasn't clear how they would be stable on a comet nucleus exposed to vacuum and varying solar radiation. Another researcher proposed that the features might come from minerals formed under high pressure, materials that don't exist in ordinary asteroids because they form only in planetary interiors and haven't been excavated by impacts that might expose them. But high-pressure minerals would need to survive in 3 Atlas from its formation in another stellar system, remaining somehow exposed at the surface despite eons of space weathering. None of the explanations were satisfying. Each required special circumstances or unusual conditions to explain a single spectroscopic observation, and multiple observations all showed features that didn't fit standard interpretations. By July, Sokolov had accumulated what she called a spectroscopic zoo, a collection of spectra from different dates showing a bewildering variety of features that seemed to cycle through the object's surface properties, without following any obvious pattern. Most troubling was the rapidity of change. Surface evolution on comets typically proceeds gradually, with fresh ice exposing as overlying dust sublimates away, with colors changing slowly as space weathering alters surface composition. The timescale for significant change is usually weeks or months, not days. But 3 Atlas's spectrum could change substantially in less than a week, showing different features in observations separated by only a few days. This rapid evolution suggested either a very active surface with vigorous sublimation constantly exposing new material, or something more complex than passive response to solar heating controlling what materials were visible. Sokolov published her spectroscopic timeline in August, presenting 17 spectra taken between February and July showing the progression of changes. The paper carefully avoided exotic speculation, noting the unusual behavior but not proposing artificial explanations. But in private communications and conference hallway conversations, Sokolov expressed puzzlement and admitted she couldn't explain the observations through standard cometary processes. The spectroscopic evolution of 3 Atlas seemed to violate expectations about how surfaces should behave, changing too rapidly and too discontinuously to fit comfortable models. Other spectroscopists confirmed Sokolov's findings using independent observations. The mysterious absorption features appeared in multiple datasets from different telescopes. The rapid evolution was reproducible, not limited to any single instrument or observer. 3 Atlas's surface composition was genuinely changing in ways that didn't match well-studied comets, following patterns that suggested either unknown processes or active manipulation of what materials were exposed to observation. The spectroscopic puzzles added another layer to the growing sense that 3 Atlas was extraordinary. Combined with rotation stability and thermal excess, the unusual spectroscopic behavior created a pattern of anomalies that became increasingly difficult to explain through coincidental alignment of rare but natural properties. Each individual observation might be explicable with effort, but together they suggested something beyond our experience, something that didn't fit comfortably into categories designed to classify natural solar system objects. Rest with these accumulating mysteries as summer advanced toward fall, and the discovery of the 9 companions approached. The stage was being set for the observation that would transform speculation into serious consideration, that would force even skeptical scientists to acknowledge that something unprecedented was occurring, that would capture global attention and spark debates far beyond astronomical circles about our place in the cosmos and whether we are truly alone. Part 3. Discovery of the Companions, September 2025, Chapter 5. September 14th, the night everything changed. September 14, 2025, dawned clear and cool on Mauna Kea, that sacred mountain in Hawaii, where a dozen world-class telescopes crown the summit at an altitude of over 4,000 meters. Dr. Sarah Chen had telescope time scheduled on the Subaru telescope, 8.2 meters of light-gathering power, equipped with some of the most sophisticated instruments available to astronomy. Chen had been observing 3 Atlas regularly through summer, tracking its approach toward perihelion, monitoring for changes in cometary activity as solar heating intensified. Chen's observing plan for that night focused on detailed imaging of 3 Atlas's coma, that faint cloud of gas and dust surrounding the nucleus. She wanted to map the coma's structure in multiple wavelengths, looking for jets, filaments, or other features that might reveal how the nucleus was outgassing, where active areas were located, whether the activity pattern showed any unusual characteristics. To accomplish this, she planned to use a technique called image enhancement processing, where multiple exposures would be combined mathematically to reveal structures fainter than any single image could show. The observations proceeded smoothly through the night. Chen took dozens of exposures through different filters, building a comprehensive dataset covering wavelengths from near-ultraviolet through visible and into near-infrared. Each exposure lasted several minutes, long enough to detect faint features while short enough that the object's motion across the sky wouldn't blur the image excessively. Between exposures, Chen monitored data quality, checking focus, ensuring tracking was accurate, verifying that no problems were developing with the telescope or instruments. As dawn approached and the observations concluded, Chen downloaded all the data from the night's work. She would spend the coming hours and days processing these images, applying enhancement techniques, searching for interesting structures in the coma, comparing results to previous observations to track how activity was evolving. This was normal procedure after any observing session, the beginning of analysis that would eventually result in scientific papers and presentations, sharing results with the broader community. That morning, back in her office at the University of Hawaii, Chen began the image processing. She started with standard calibrations, removing instrumental signatures, correcting for variations in pixel sensitivity, subtracting background light from the sky. Then she began combining multiple images, using algorithms designed to enhance faint features while suppressing noise. The primary object appeared as expected, a slightly fuzzy blob with a faint tail pointing away from the sun, typical of comets at that solar distance. But as Chen applied more aggressive enhancement, pushing the processing to reveal the faintest possible features at the limits of detectability, something unexpected emerged. Around the main body, at distances of roughly 2,000 kilometers, appeared 9 point-like sources. They were faint, barely above the noise level even after enhancement, but they appeared consistently in multiple independent images. 9 points of light, arranged in a pattern around 3 Atlas's nucleus. Chen's first reaction was skepticism directed at her own work. Had her image processing introduced artifacts, spurious features created by the enhancement algorithms, rather than representing real objects? She checked carefully, examining individual raw images before any processing. The point sources were present, though barely visible without enhancement. She processed subsets of the data independently, using different algorithms, varying parameters to see if the features persisted. They did. The 9 points were real, actually present in the telescope data, not artifacts of analysis. Next, Chen considered whether the points might be background stars or galaxies, distant objects that happen to lie along the line of sight to 3 Atlas. This is a common concern when detecting faint objects near bright ones. But Chen had taken images hours apart during the night, and the point sources moved with 3 Atlas, maintaining their positions relative to the nucleus while the background stars remained fixed. They were traveling with the object, not chance alignments with distant background sources. Chen measured the positions of the 9 points carefully, determining their locations relative to the nucleus and relative to each other. What she found made her immediately call colleagues to verify her analysis before announcing anything publicly. The 9 weren't randomly scattered around 3 Atlas. They formed a geometric pattern, arranged in what appeared to be a circle centered roughly on the nucleus, each maintaining approximately equal distance from its neighbors. The geometry was too orderly to be accidental. Chen calculated the probability that 9 randomly positioned fragments would arrange themselves into such a regular pattern. The number was vanishingly small, less than 1 chance in a trillion. Something about this arrangement was organized, structured, suggesting either unknown physics constraining the positions or active control maintaining the formation. Chen contacted Dr. James Wu at Caltech, a specialist in orbital dynamics who had been studying 3 Atlas's rotation properties. She sent him her processed images and asked if the geometric arrangement could be explained through any natural process. Wu examined the data carefully before responding. His answer was cautious but clear. He knew of no natural mechanism that could create and maintain such precise geometric arrangement. Gravitational effects couldn't do it at those separation distances. Electromagnetic forces would require implausibly strong charges. The formation appeared to be actively maintained through some mechanism that wasn't immediately obvious from the observations. Chen then reached out to other observers who had recent data on 3 Atlas, asking them to check their images for similar features. Within 48 hours, confirmations arrived from multiple facilities. The Keck Observatory in Hawaii had detected the companions in images from September 12th, 2 days before Chen's observation. The Gran Telescopio Canarias in Spain found them in data from September 10th. The Very Large Telescope in Chile had captured them in images from early September. The companions were real, reproducible across independent observations from different telescopes on different continents. On September 17th, Chen published an announcement on the Astronomer's Telegram, a rapid communication service for transient astronomical events. Her announcement was deliberately understated, presenting the observation without excessive interpretation. We report the detection of 9-point sources at approximately 2,000 km separation from interstellar object C/2025, a 3-3I Atlas. The sources are detected in multiple images, obtained September 14 with Subaru/Hai Chao, and have been confirmed in archival data from other facilities. The sources appear to form a geometric arrangement around the primary nucleus. The nature and origin of these companions is presently unclear. Continued monitoring is strongly encouraged. The response within the astronomical community was immediate and dramatic. Within hours, hundreds of astronomers had read the announcement. Within a day, dozens of telescopes had been redirected toward 3 Atlas to observe the companions independently and gather additional data. Within a week, the discovery was making headlines not just in specialized astronomy publications, but in mainstream media worldwide. The geometric formation of 9 companions around an interstellar visitor was too unusual, too provocative, too potentially significant to be ignored. Skeptics immediately began proposing alternative explanations. Perhaps the companions were background stars that coincidentally appeared near 3 Atlas and seemed to move with it due to observation timing. But this was easily ruled out by observations showing the companions maintaining their positions over multiple nights, while background stars shifted due to parallax and relative motion. Perhaps the companions were image artifacts, features created by light scattering in the telescope or data processing anomalies. But independent confirmation from multiple facilities, using different telescopes and instruments, ruled out instrumental effects. The most plausible natural explanation involved fragmentation. Perhaps 3 Atlas had broken apart at some point, perhaps during passage close to Jupiter or another planet, or perhaps due to tidal stresses during some earlier close stellar passage. The fragments might have been ejected in a way that happened to create geometric arrangement, perhaps through symmetric splitting of a parent body. But this explanation struggled to account for several observations. Fragments from a single breakup event should disperse over time, their slightly different velocities causing them to spread out along the orbital path. Yet the companions maintained precise spacing over weeks of observation, showing no sign of drift that should be inevitable if they were independent bodies following slightly different orbits. Moreover, breakup events typically produce irregular fragment distributions, not geometric patterns. Comets that split usually create chains of fragments strung along the orbit, not circular arrangements. The only way to produce the observed geometry through fragmentation would require an incredibly symmetric breakup with fragments ejected at precisely calculated velocities in precisely calculated directions, all happening to align in a way that created and maintained the circular formation. The improbability approached the impossible. Wu performed detailed dynamical analysis, tracking how the companions moved relative to 3 Atlas and relative to each other over the 3 weeks between first detection and his analysis in early October. His results were published in a rapid turnaround paper that appeared just 2 weeks after Chen's discovery announcement. Wu showed that the companions maintained constant separation from the nucleus and constant angular positions relative to each other, to within measurement precision. This stability was incompatible with independent orbits. Objects orbiting a common center of mass would show relative motion as they traveled around their orbits at different rates, depending on their distances from the center. But the companions showed no such motion. They moved as if rigidly connected to an invisible structure centered on 3 Atlas, as if held in formation by forces that shouldn't exist at those separation distances. The discovery of the companions transformed discussion about 3 Atlas from polite scientific exchange into passionate debate about extraordinary possibilities. The rotation stability, thermal excess, and spectroscopic puzzles had created unease, a sense that something was unusual. But the companions elevated that unease into serious consideration that 3 Atlas might not be natural, that the accumulating anomalies might indicate technology rather than geology, that we might be witnessing humanity's first confirmed encounter with artificial objects from beyond our solar system. Not everyone accepted this interpretation. Many researchers maintained that natural explanations surely existed, that we simply hadn't identified the right combination of circumstances and processes to explain observations through conventional physics. They pointed out that the universe has surprised us before, with phenomena that initially seemed impossible, but eventually found natural explanations. They argued that invoking technology was premature, that scientific caution demanded exhausting all natural possibilities before entertaining such extraordinary hypotheses. But as September ended and October began, as 3 Atlas approached ever closer to perihelion, and the companions maintained their impossible formation, as more data accumulated and more analysis failed to produce satisfying natural explanations, even skeptics began to acknowledge that something genuinely unprecedented was occurring. The question was no longer whether 3 Atlas was unusual. That much was certain. The question was whether unusual meant natural but rare, or whether it meant something more profound, something that would change our understanding of our place in the cosmos. Rest now with this pivotal discovery. Let the image of 9 companions arranged in geometric precision sink into your peaceful mind. This was the observation that changed everything, that transformed 3 Atlas from curious anomaly into potential watershed moment in human history. The discovery sparked debates that continue, raised questions that may never be fully answered, invited us to seriously consider possibilities we had previously relegated to speculation and science fiction. Whether the companions ultimately prove natural or artificial, their existence and behavior challenged our assumptions and expanded our sense of what might be possible in this vast, mysterious universe we inhabit. Chapter 6. The formation holds through late September and into October. Astronomers around the world maintained intensive observation campaigns focused on 3 Atlas and its 9 companions. Every clear night, dozens of telescopes turned toward the object, gathering data across wavelengths from radio through visible light to infrared and X-rays. The observational resources dedicated to this single object were unprecedented, rivaling campaigns for major astronomical events like supernova discoveries or gravitational wave counterparts. The primary question driving these observations was simple but profound. Would the formation hold? If the companions were genuinely independent fragments, natural debris from some fragmentation event, they should drift apart over time as tiny differences in their orbits accumulated. If the formation was being actively maintained, whether through unknown natural forces or through technological control, the geometry should persist with the precision it had shown in early observations. As the days passed and data accumulated, the answer became clear. The formation was holding, not just approximately but with extraordinary precision. Wu continued his dynamical analysis, measuring companion positions in hundreds of images taken over 4 weeks. He found no evidence of drift. Each companion maintained its distance from the nucleus and its angular position relative to its neighbors to within 1% of ideal spacing. This stability over a month of observation, spanning a quarter of 3 Atlas's rotation period, and covering significant changes in viewing geometry as Earth and the object moved, was incompatible with independent orbits under gravity alone. More puzzling still, detailed photometric analysis by Santos revealed that the companions weren't simply maintaining position. They were also maintaining brightness relationships with each other and with the primary nucleus. She tracked how the companions' apparent brightness changed as viewing angle shifted and solar illumination varied. Natural independent objects should show different brightness variations as their irregular shapes rotated, and different surface features came into and out of view. But the companions varied in lockstep. Their brightness patterns correlated in ways that suggested coordinated behavior rather than independent rotation. Infrared observations by Tanaka added another layer to the mystery. The companions were generating thermal emission, infrared radiation beyond what solar heating alone could produce, just like the main nucleus. But the pattern of excess emission wasn't uniform. 3 of the companions showed significantly higher temperatures than the others, suggesting internal heat generation at different rates. This differentiation implied specialization, as if the companions had different functions or roles rather than being identical fragments from a symmetric breakup. Spectroscopic observations proved challenging for the companions due to their faintness, but several observers obtained low-resolution spectra using long exposures and large telescopes. The spectra showed features broadly similar to the main nucleus, but with subtle differences in relative strengths of various absorption bands. Again, the pattern suggested differentiation rather than uniform composition. If the companions were fragments from 3 atlas breaking apart, they should show the same surface composition, unless the original body had been strongly heterogeneous, with different compositions at different locations. Such heterogeneity is possible but unusual in small bodies. The most remarkable observation came from radar attempts to detect the companions. The Arecibo Observatory in Puerto Rico transmitted toward 3 Atlas during a window when the geometry was favorable, hoping to detect radar echoes from the companions separately from the main nucleus. The echoes revealed something unexpected. The companions appeared to have higher radar reflectivity than the nucleus, as if they were more metallic or had smoother surfaces. Moreover, the radar signatures suggested the companions were smaller than initial optical observations had implied, perhaps only tens of meters rather than hundreds of meters in diameter. This size discrepancy was puzzling. Objects tens of meters across shouldn't be bright enough in visible light to have been detected in Chen's original observations, unless they were highly reflective or actively emitting light. But cometary fragments are typically dark, absorbing most incident light rather than reflecting it brightly. The companions' apparent brightness in optical wavelengths, combined with small size inferred from radar, suggested they were either unusually reflective or that optical observations were detecting something other than simple reflected sunlight. One research group proposed that the companions might be surrounded by their own minicomi, small dust clouds that scattered sunlight and made the objects appear larger and brighter than they actually were. This could reconcile the optical and radar observations if each companion was a small solid nucleus wrapped in its own faint dust halo. But attempts to detect these hypothetical minicomi using high-resolution imaging failed to find evidence for such structures. The companions appeared point-like even in the sharpest images, showing no resolved comas or envelopes. As October progressed and 3 Atlas approached ever closer to Perihelion, now scheduled for October 29th, the companions maintained their formation with unwavering precision. They were now receiving intense solar radiation, the heating that should cause any ice to sublimate vigorously, that should create asymmetric forces potentially disturbing their positions. Yet they held their formation, each maintaining its assigned position, as if connected to an invisible framework that constrained their movement. The scientific community was by now deeply divided. Roughly a third of researchers working on 3 Atlas believed the formation must be actively maintained through some mechanism we hadn't identified yet, whether natural or artificial. Another third maintained that natural explanations would eventually be found, that we simply needed more data or better models to explain observations through conventional physics. The remaining third admitted profound uncertainty, unable to choose between interpretations based on available evidence, uncomfortable with both natural explanations that seemed increasingly contrived and artificial explanations that challenged comfortable assumptions about our cosmic isolation. The debate played out in papers, at conferences, in email exchanges and social media discussions. Those favoring natural explanations proposed increasingly elaborate scenarios. Perhaps the companions were connected by invisible tethers of dust, too fine to be observed directly. Perhaps electromagnetic forces were holding them together through some configuration of surface charges we hadn't properly modeled. Perhaps they were all parts of a larger structure that was mostly empty space, connected by materials transparent to light, but capable of maintaining structural integrity. Those open to artificial explanations pointed out that the simplest interpretation of observations was active control, that all the anomalies made sense if 3 Atlas was a constructed object rather than a natural one, that rotation stability, thermal excess, spectroscopic changes, and companion formation all suggested technology rather than geology. They noted that, while extraordinary claims require extraordinary evidence, sometimes the extraordinary hypothesis is actually simpler than the elaborate natural explanations required to avoid it. The public followed these debates with intense interest. News coverage of 3 Atlas had grown steadily through summer as various anomalies were discovered and reported. But the discovery of the companions elevated media attention to unprecedented levels. Major newspapers ran front-page stories. Television news programs devoted significant coverage to explaining what the companions were and why they mattered. Online forums and social media platforms filled with discussion and speculation, sometimes informed by scientific understanding, sometimes wildly imaginative, always revealing that people everywhere were fascinated by the possibility that we might not be alone in the universe. Opinion polls conducted in late September showed remarkable consistency across cultures and nations. When asked whether they thought 3 Atlas was natural or artificial, roughly 60% of respondents chose artificial, 20% chose natural, and 20% admitted they didn't know. When asked whether they hoped 3 Atlas would prove artificial, indicating the existence of other intelligent life, over 70% said yes. The public, it seemed, wanted to believe, not because they desired invasion or feared judgment, but because the universe felt less lonely with the possibility that consciousness emerged elsewhere, that intelligence might be common rather than rare, that we might someday communicate with civilizations beyond our own. But wanting to believe and having evidence sufficient to believe are different things. As October progressed toward the 29th, toward perihelion and conjunction when 3 Atlas would disappear behind the sun, the question remained unresolved. The companions held formation with impossible precision. The anomalies accumulated and strengthened. But definitive proof of artificial origin remained elusive, always tantalizingly close, but never quite achieved, leaving everyone in uncomfortable uncertainty about what they were witnessing. Rest with this uncertainty as we approach the moment of conjunction. The formation holds, impossible yet observed, challenging our understanding yet undeniably real. The companions maintain their geometric precision as 3 Atlas races toward its appointment with the sun, toward the moment when it will vanish behind solar fire and all observation will cease, when questions that have been theoretical will become urgent, when the need to know will become impossible to ignore. The story builds toward this moment, toward October 29th, toward the day everything changed, and the mystery deepened beyond anything we had experienced before. Final meditation, the cosmos and consciousness as the final moments of this documentary approach, as your consciousness hovers in that liminal space between waking and sleep, let us contemplate one last profound question that 3 Atlas invites us to consider. What does it mean to be conscious in a universe that may or may not contain other consciousness? Consciousness itself remains one of the deepest mysteries in science. We experience it directly, intimately, constantly. Every thought you have, every sensation you feel, every emotion that moves through you all arise from consciousness. Yet we cannot fully explain how consciousness emerges from the physical processes in our brains, how electrochemical signals between neurons give rise to subjective experience, to the felt quality of being someone, of having an inner life. This is what philosophers call the hard problem of consciousness, and despite centuries of philosophical investigation and decades of neuroscientific research, we remain far from a complete understanding. What we do know is that consciousness in humans, and probably in many other Earth species, emerges from specific types of information processing in complex nervous systems. Our brains contain roughly 86 billion neurons, each connected to thousands of others through synapses, creating networks of staggering complexity. These networks process information about the world, about our bodies, about our memories and goals and emotions. And somehow, mysteriously, from all this processing emerges the unified feeling of being a conscious self, an experiencing subject who perceives and thinks and feels and chooses. If consciousness can emerge from matter arranged in these specific ways on Earth, there seems no reason it couldn't emerge elsewhere in the universe, wherever similar conditions exist. The same physical laws operate everywhere. The same atoms and molecules exist throughout the cosmos. If carbon-based chemistry can support the emergence of consciousness here, it should be able to do so on any planet with suitable conditions. And there is no reason to assume consciousness requires carbon specifically. Silicon-based life might be possible, or forms of life based on entirely different chemistry than what we know from Earth. Perhaps consciousness can emerge from any sufficiently complex information processing system, regardless of its physical substrate. This possibility that consciousness might be common, might arise naturally wherever conditions permit sufficient complexity, has profound implications for how we understand ourselves and our place in the universe. If we are not unique, if consciousness has emerged countless times throughout cosmic history, then we are part of a larger community of minded beings, separated by vast distances but united by our common capacity to experience, to think, to wonder about existence and meaning and purpose. But if consciousness is rare, if the conditions that allowed it to emerge on Earth are so specific and improbable that they have occurred nowhere else, or only in a handful of places scattered across billions of galaxies, then our responsibility becomes even more profound. We would be among the few, or perhaps the only place where the universe has become aware of itself. The destruction of Earth and extinction of humanity would mean not just our own end, but potentially the end of all consciousness. The return of the universe to unconscious existence where nothing thinks or feels or wonders, where existence continues but no one experiences it. 3 Atlas, in its ambiguity about natural versus artificial origin, invites us to reflect on these possibilities. If it proves natural, if all the anomalies eventually find explanation through physics and chemistry, we already understand or will understand with more research, then we learn nothing definitive about whether we are alone. The question remains open, to be addressed through other observations, through future discoveries, through the gradual accumulation of evidence from searching the cosmos for signs of life and intelligence. But if 3 Atlas proves artificial, if the companions and thermal excess and impossible stability ultimately indicate technology rather than geology, then we learn something profound about the universe and our place in it. We learn that consciousness has emerged elsewhere, that intelligence is possible beyond Earth, that somewhere in the galaxy or beyond, minds different from ours have asked questions similar to ours, have developed technology capable of exploring beyond their birth worlds, have achieved things we are only beginning to imagine might be possible. Either outcome would be significant. Either would teach us about the universe and about ourselves. But the implications differ profoundly, and which possibility proves true will shape humanity's future in ways we cannot yet fully anticipate. This is why 3 Atlas matters so much, why its ambiguous observations have generated such intense interest and debate, why resolution of its nature would be not merely another scientific discovery, but a pivot point in human history and human self-understanding. As you rest now, drifting peacefully toward or into sleep, carry with you this sense of living at a significant moment in the long story of human engagement with the cosmos. Whether we are alone or not, whether 3 Atlas is natural or artificial, we are alive at a time when these questions can be investigated seriously through scientific observation, rather than merely philosophical speculation. We possess technology that allows us to detect objects from other star systems, to analyze their properties in extraordinary detail, to make informed judgments about probabilities and possibilities. This capability, developed over centuries of technological advancement and scientific refinement, gives us unprecedented power to explore fundamental questions about existence and meaning that humans have pondered since we first developed capacity for abstract thought. The mystery continues. 3 Atlas moves through space somewhere beyond our current ability to observe it effectively, carrying its secrets with it, perhaps forever unknowable in their full depth, perhaps eventually to be revealed through future missions or future observations or future insights that we cannot currently anticipate. The universe holds its mysteries close, yielding understanding slowly, demanding patience and persistence and humility from those who seek to comprehend it. But this gradual revelation is itself part of the beauty and wonder of existence. If everything were immediately obvious, if all questions had easy answers, if mystery never provoked us toward deeper inquiry, the universe would be a less interesting place, and we would be less interesting beings. The presence of genuine mystery, of questions that challenge our understanding and invite continued exploration, gives life much of its meaning and purpose. We are built to be curious, to seek understanding, to wonder at the vast complexity and beauty of the cosmos we inhabit. 3 Atlas and its companions, whatever their ultimate nature, have given us gift of renewed wonder, reminder that the universe still holds surprises, that our journey of discovery continues with new chapters yet to be written. Sleep now, deeply and peacefully, secure in the knowledge that mysteries exist and that this is cause for joy rather than anxiety. The story continues beyond this documentary, beyond your sleep tonight, beyond any individual human life into the deep future where humanity's descendants, whoever and whatever they may be, will continue the grand project of understanding the cosmos and our place within it. Dream well. Dream of possibilities and wonders, of questions that invite rather than demand, of a universe rich enough to support consciousness contemplating its own existence. And rest knowing that tomorrow, when you wake, the stars will still be there, the mysteries will still invite exploration, and the story of 3 Atlas and what it might mean will continue to unfold in ways we cannot yet imagine, but can anticipate with curiosity, hope, and wonder. Extended Epilogue. Reflections on mystery and wonder as our long journey through the story of 3 Atlas draws toward its close, as your consciousness drifts ever deeper toward complete rest and sleep. Let us take time to reflect on what this experience of cosmic mystery teaches us about ourselves, about science, about the human need to explore and understand, and about our evolving relationship with the vast universe that surrounds us. The story of 3 Atlas is, at its heart, a story about encountering the unknown and wrestling with ambiguity. Throughout human history, We have been confronted with phenomena we couldn't immediately explain, with observations that challenged our understanding, with mysteries that resisted easy resolution. Our response to these encounters reveals much about who we are as a species, about how we think, about what drives us forward in the never-ending quest for knowledge and comprehension. In earlier eras, when humans encountered the unexplainable, they often invoked supernatural explanations, attributing mysterious phenomena to gods or spirits or forces beyond natural law. Thunder and lightning were the anger of Zeus or Thor. Eclipses were dragons devouring the sun. Diseases were punishments for moral transgressions. This pattern of invoking supernatural explanation for natural phenomena was universal across cultures, appearing in some form in every human civilization we know of throughout recorded history, and probably extending back into prehistory, before written records began. But gradually, painfully, over centuries and millennia, humanity learned to resist the temptation towards supernatural explanation, to persist in searching for natural mechanisms, even when those mechanisms weren't immediately obvious. We learned that thunder results from rapid heating and expansion of air by lightning's electrical discharge, not from divine anger. We learned that eclipses follow from geometric alignments of sun, moon, and earth, not from cosmic dragons. We learned that diseases have biological causes, bacteria and viruses and genetic factors, not moral origins. Each advance in understanding represented a triumph of patience and careful observation over the easy comfort of supernatural explanation. This gradual shift from supernatural to natural explanation is one of humanity's greatest intellectual achievements. It required developing new ways of thinking, new methods for testing ideas against observations, new humility about admitting when we don't know rather than inventing comforting stories to fill gaps in understanding. The scientific method, that disciplined approach to investigating nature through observation, hypothesis, prediction, and testing, emerged from this long struggle to understand the world through evidence rather than assumption or authority or tradition. And now, in the 21st century, we face a new kind of challenge to this hard-won scientific worldview. The question 3 Atlas raises is not whether to invoke supernatural explanation, not whether gods or spirits are involved. No serious scientist considers such possibilities. But the question is whether natural explanation is sufficient, or whether we must expand our categories to include artificial explanation, technology created by intelligence but not supernatural, engineered objects that follow physical law but resulted from deliberate design rather than random processes. This is a genuinely new situation for science. Throughout history, the distinction between natural and artificial has been clear and unambiguous. Natural things are produced by physical processes operating without guidance or purpose. Artificial things are produced by intelligent beings with intentions and goals. On Earth, this distinction is obvious. We can easily tell the difference between a rock formed by geological processes and a tool shaped by human hands, between a bird's nest built by instinct and a house built by human engineering, between random patterns in sand dunes and deliberate patterns in agricultural fields. But when we look beyond Earth, the distinction becomes less clear. How do we recognize artificial objects created by non-human intelligence? What signatures would distinguish technology from natural phenomena when we don't know what forms technology might take? What materials might be used? What designs might be preferred by minds that evolved under different conditions than we did? This is not a hypothetical question anymore. 3 Atlas and its 9 companions force us to confront it practically, to develop criteria for distinguishing natural from artificial when both possibilities seem to violate our intuitions in different ways. The scientific community's response to 3 Atlas reveals our collective wisdom and our collective limitations. On one hand, the insistence on exhausting natural explanations before entertaining artificial ones reflects hard-won understanding that nature is far more creative than we often give it credit for, that phenomena that seem impossible often find natural explanation once we understand them properly. This conservatism has served science well, preventing premature acceptance of extraordinary claims, maintaining standards of evidence that ensure our theories actually describe reality, rather than merely reflecting our hopes or fears or biases. On the other hand, excessive conservatism can become dogmatism, can prevent recognition of genuinely new phenomena, can cause us to dismiss evidence that doesn't fit comfortable categories. At what point does healthy skepticism about extraordinary claims become unhealthy refusal to seriously consider possibilities that make us uncomfortable? When does insisting on natural explanation become a kind of assumption, an unexamined belief that everything must be explicable through physics and chemistry we already understand? These are not easy questions, and different scientists answer them differently based on temperament, experience, and philosophical commitments that often operate below conscious awareness. The debate about 3 Atlas, the tension between those favoring natural explanations and those open to artificial possibilities, reflects these deeper questions about how science should operate when confronting genuinely unprecedented situations. There are no perfect answers, no algorithmic procedures for deciding when evidence becomes sufficient to accept extraordinary conclusions. Science is a human enterprise, conducted by human beings with human limitations and biases and emotions, not a mechanical process that automatically generates correct answers from data. We do our best, we argue and debate, we gather more evidence and refine our thinking, and sometimes we reach consensus, and sometimes we don't. What makes the 3 Atlas situation particularly challenging is that both natural and artificial explanations seem to require accepting things that violate our intuitions. Natural explanation requires accepting that multiple rare properties happen to combine in one object by chance, that coincidences stacked upon coincidences in ways that seem improbable, but aren't technically impossible. Artificial explanation requires accepting that intelligence has emerged elsewhere in the galaxy, that some civilization achieved technological capability sufficient to build and launch interstellar objects, and that we are witnessing evidence of this technology. Both conclusions are profound. Both would change how we understand the universe. Neither is comfortable or easy to accept. Perhaps this ambiguity is itself meaningful. Perhaps the universe is showing us that reality doesn't always divide neatly into categories we create, that sometimes the most honest answer is genuine uncertainty, that intellectual humility requires admitting when we simply don't know rather than forcing conclusions that aren't yet warranted by evidence. Learning to live with ambiguity, to remain curious in the face of unresolved mystery, to continue investigating without demanding immediate definitive answers. These are skills that serve us well not just in science but in all aspects of life where certainty proves elusive. The public response to 3 Atlas, the widespread fascination with this object and its companions, reveals something important about human nature and our relationship with the cosmos. Opinion polls consistently showed that most people hoped 3 Atlas would prove to be artificial, that the anomalies would indicate technology rather than unusual natural properties. This hope wasn't primarily about wanting to be saved by advanced aliens or fearing invasion by hostile intelligence. It was simpler and more poignant than that. People wanted to know we are not alone. They wanted the universe to be populated, to contain other minds wondering as we wonder, other civilizations facing the same existential questions about meaning and purpose that humans have grappled with throughout history. This deep human desire for cosmic companionship makes sense when we reflect on our situation. We are, as far as we know with certainty, the only conscious, technologically advanced intelligence in the entire observable universe. We emerged on one planet orbiting an ordinary star in an ordinary galaxy, and we have found no definite evidence of any other intelligence anywhere, despite searching carefully, and despite theoretical expectations that Earth-like planets should be common and life should emerge wherever conditions permit. This isolation is, when you really contemplate it, profoundly strange and somewhat terrifying. Are we really alone? Is consciousness so rare that in all the vastness of space, only on Earth did matter organize itself in ways that produced self-aware minds capable of pondering their own existence? The implications of being alone are almost too large to fully grasp. It would mean that in all the hundreds of billions of galaxies, each containing hundreds of billions of stars, each potentially hosting multiple planets, something about the path from chemistry to life to intelligence is so improbable that it happened only once. It would mean that human civilization, for all our flaws and conflicts and limitations, represents something utterly unique in the cosmos, the only place where the universe has become conscious of itself, the only place where questions about meaning and purpose are even being asked. The responsibility this would place on us, to preserve ourselves and eventually spread beyond Earth to ensure consciousness doesn't vanish from the universe, is almost overwhelming to contemplate. But if we are not alone, if intelligence is common and 3 Atlas represents evidence of another technological civilization, then everything changes. We become one among many, participants in a galactic community we are only beginning to discover. Our problems and achievements gain different perspective when we imagine them contextualized against other civilizations facing their own challenges. The questions about meaning and purpose that have driven human philosophy and religion for millennia might find new answers, or at least new framings, when we learn how other minds approach these eternal questions from their own unique perspectives, shaped by their own evolutionary histories and cultural developments. 3 Atlas, whether ultimately proven natural or artificial, has given us a gift regardless of its nature. It has given us permission to seriously consider these questions, to move them from the realm of speculation into the realm of scientific investigation, to acknowledge that determining whether we are alone is not just philosophical musing but practical inquiry that can be pursued through careful observation and analysis. It has reminded us that the universe is full of mysteries worth investigating, that the cosmos retains capacity to surprise us, that despite all we have learned, we remain at the beginning of a journey of discovery that may never end. As you drift now toward sleep, carrying these thoughts into dreams, consider what it means to live in a time of such profound questions and genuine mysteries. Consider the privilege of being alive when technology allows us to detect objects from other star systems, to analyze their properties in detail, to seriously investigate whether we are alone. Consider the wonder of existing in a universe vast enough and old enough that intelligence might have emerged in many places, might be common rather than rare, might be waiting to be discovered if only we are patient and careful enough in our searching. Sleep now, deeply and peacefully, knowing that the mystery continues, that 3 Atlas moves through space carrying its secrets with it, that the universe holds wonders we are only beginning to imagine. Dream of stars and possibilities, of questions that invite wonder rather than demanding immediate answers, of a cosmos stranger and richer than any fiction we could invent. Dream well, rest fully, and remember when you wake that we live in extraordinary times, that the greatest discoveries may still lie ahead, and that the story of humanity's relationship with the cosmos is still being written, with chapters yet to come that we cannot yet conceive but can anticipate with curiosity and hope. The story of 3 Atlas continues somewhere in the dark, and we continue with it, forever wondering, forever searching, forever looking up at the night sky with questions that may someday receive answers beyond anything we currently imagine. Good night. Rest deeply, and carry these mysteries gently into your dreams, where anything is possible and wonder needs no justification. The end and also the beginning. The mystery continues. So do we.